How's the meeting going so far?
Sitting there swimming and keep our head above water. You know.
Yeah.
I don't know, that works.
You know how that works. It's crazy.
We haven't done our business part yet, but we can kind of dice it up if we want to.
Yeah.
I can go sit and you doing your business.
You can want to listen to us with that part? You
Sure,
want to
yeah.
go first?
No, whatever you want.
Okay.
I have time to hang around.
Got it. You can hang
Just
on.
wanted to make sure I was here on time. Yeah.
Okay.
Yeah.
Thanks.
So are you on, Mark?
Yeah.
Okay, got it. Well, I think we'll get started a little delayed in waiting for a couple people we're still waiting for, but we have our first presenter here, but we can go to the business part firsthand. We're recording with the intent that for the presentations, maybe we can have these to be part of our website. If somebody's not here, could come back and listen to it. As I was telling Steve, for those of us who are older, sometimes we remember something at a different time and maybe we can go back and remember what they said. Or at least we can Google it and figure out what they said and what they meant when they gave us some information. So in that, we're recording to try to present this to maybe some of the members that are not able to make it. So we'll get started. I'm Jack Kaltenberg, and I still remember that. I'm still good for a little while yet, but I thought one of the introductions would be if introducing the staff here. You hear them, maybe not see them much, but you know these are the people doing all the work. So I told them also, and maybe you can introduce them, but then they can say something about them. I'm the only person that can see the faces if they're not telling the truth about themselves. So I told them you have the ability to change who you are, and then I can decide if it's truthful based on the other 4 or 5 people watching. So go ahead.
Hello everybody, Shawn Miranpuri, General Manager of Crop Improvement, and our first staff member is Mark.
Yep, I'm Mark, most people know me, going on about 10 years now, working all aspects of the lab, been working on also getting passed on our audits that we've had lately in the lab, and we also just sold our software program to a new company in Oregon called Pure Seed. So that's what I've been working on lately.
And again, the key person now, along with Shaminder, on our computer program that we're marketing to a number of, and how many different states are using our program now?
I think it's about 6 now with the new, including us.
Yeah, and Minnesota's kind of on the hook
Yeah.
to maybe take it on, since that program we started how many hundreds of thousands of dollars ago?
700,000.
700, you said? And so we're kind of the only one, and but moving along from what we were doing in a DOS system and all that work by Gene Anderson, and now we're able to market to those institutions much like us that need some of the things that we do. So Mark's kind of the lead person, and Schminder. Okay.
Amanda.
Hi, I'm Amanda Magley. I've been here for about a year, and I do a lot of analysis work in the lab. I do mixtures, flowers, grasses, all sorts of things. And I do germination counts and also field inspections.
I'm Nick. I specialize primarily in planting seeds and counting the germination. Been here 3-4 years, and yeah, I'm just going with the flow, really.
Also does a lot of herbicide testing.
Right. Like,
Hi, Armand Singh. Been here for 6 years. I did some germination seed count. I also do purity noxious just for legumes, good for natives, and yep.
And he's the key person. He enters all the samples and reports them. So.
Thank you.
Well, good. And as you know, Shaminder's our general manager. An interesting journey since last winter.
Sure.
And John's health conditions and such was kind of an abrupt change in need. And we were very, very happy to have Shminder available and willing to take on maybe the things that aren't as easy for her. Yeah, I think you give her 40 different seeds and mix them together and she can tell you what it is.
Try.
Yeah, but see, that's the key thing, is there's a lot of people that say, yeah, I got it. But the fact is you say try, which means she's always improving. Subsequently, that's what passes on to the other. So your job is to figure out how to replace her so she can do more of the things that we as a board, she gets to do, and sometimes are kind of a surprise, right?
Mhm.
Like, oh yeah. Or we're kind of missing Gene Amerson today. You heard his back.
He
And
hurt his back.
he was our general manager for how long?
36 years.
Yeah, so he has a historical memory, and that's in favor of us, all of us guys that have gray hair. Sometimes we can bring some things together because of change, but sometimes it's because, well, we tried that and here's why it didn't work, but maybe somebody younger can figure out why we should try it again. I remind that in my business, it's a family business. I got my son, and when we don't agree, I tell him, you're just lucky, Garrett. You're only half related to me. So, but basically, us working together is giving us a new spot. And one of them is, the fact that we need to address what we need to do, look forward to what we're doing, and question it all the time, because we have the ability to we have to be efficient. In a market that we all know isn't the day of, for my case, beady oats, stringing the string in between and waiting for someone to put the certified seed clasps on. So we have to go with the times. Luckily, we have the software program and some of the other things that we're doing, and so we're helpful. We love this facility. Not that 5th floor of agronomy isn't a bad place to be, but this has been very nice for us. Trying to think of anything else. We got all the staff though, right?
Yeah.
Got it. Okay.
Jeff, you
Go
just
ahead.
mentioned the best way to get to the bathroom is through that door, right?
Oh yeah, so in respect to Monsanto, who used to be this place, the first thing I did is I came and I was looking for those cord safety strips. There's one in the office over here, but I wanted to point out that this would not have been up to standards. And Shawn is acknowledging it. There was always 10 minutes of telling us where the bathrooms were in a Monsanto meeting, and then tell us about the safety strips that are over the top of that so we didn't hurt ourselves. Anybody go to some of those meetings? We're in an old, yeah, you have. Our business is in the old DeKalb Research Station, and I was telling one of the gentlemen this morning, when we got in there, as they left to the bigger facility on the west side of Arlington, there was my son Garrett found a 3-ring binder that was this thick on how to hook up a trailer. Now, being a farm kid, he's going, what? Well, anyway, needless to say, when I came into the ground, they go, that wouldn't have passed the sniff test 20 years ago.
It's a number of things, yeah.
Yeah. So anyway, maybe we'll get back into it. I'm talking too much already, so we'll get on to the other part of the agenda. If Rick, you want to give a brief?
I can do that. You got the income statement, you just got the balance, budget.
So the budget was out there. Does everyone have one?
There you
All right.
go. Well, as you know, we've been having some trying years. The last 5 years, we've lost a bundle of money. And what we're trying to do is get the holes plugged. The board is pushed forward with changes that are trying to get this budget back in line. We have some good things going on in that we sold some software and stuff like that. But originally that wasn't supposed to be to help pay bills. That was supposed to be that we can do gifts to the schools and stuff for different things, but we're having to bring it in. That brought in, it's $75,000 but it's on a 5-year payment plan, the last one, so it does help the budget. We're not going to places for annual meetings and stuff like that. We're trimming the budget as hard as we can to try to do it. So most of the guys here were at the board meeting yesterday. You know it, employees, I don't know how much you know about it or not, but that's what we're trying to do, is keep it afloat and keep it going, because I don't like to lose on my watch, so I'm gonna keep fighting to do that. And we're working on expenses as hard as we can on it, so that's where this is coming from. When you look at the annual budget, Gene Amerson put that together, and if you know anything about a budget, that is good at the day you wrote it, and then as the year goes on, things change. But right now, as the budget was written, we should have came out at about a $24,000 profit if everything goes the way it is. But that doesn't necessarily mean it's going to happen that way. But right now, we cut, if you go to the page, that's the current month, we're at a negative 79,000. Last year at this time, we were 112, okay? And the biggest income comes in June. And June is when all the field inspections, all that stuff goes in. So it's depending on how much field inspection stuff we got, because what we do on a budget is usually take a 5-year average of field inspections, because you don't know from year to year how to do it. But this is what I'm trying to bring forward. I mean, it's been 4 years that should have been done harder than what it was, and some of the stuff the board didn't know about, and so I'll just leave it at that. So are there any questions about the budget? So, all right, thank you.
It is some follow-up again. As I said earlier, we love this facility. When we moved from there, which we had, I don't know what year we started in agronomy, but there was no cost for us there. We were part of agronomy, and we were when my grandfather got into the seed business, there was 500 members of Wisconsin Crop Improvement. Okay, and that was a mechanism for moving material and inventions from the university research onto the farmers, which was our membership of distribution of small grains, and there was corn and breads and all those kind of things. So that's the history. Then upon this facility opening up, which is, we'll use the word gift with quote marks, right? Because you get stuck with a budget, you have zero cost and a gift, right? And that can be somewhat of a difference of terms. But in the process, Shawn gets to try to make sure this thing works and has a budget to keep, because they said, here's a facility and here's your responsibility, right?
Mm-hmm.
Pretty much how it went.
That's right, yeah.
And then, we as a board have understood a little better how we work in here. I have a degree in agronomy from Madison, but I understand more clearly the difference between the agronomy and CALS and the university and here. And there's walls and distance between those, depending upon how you think about it. And also, if you guys know me, when I was in school here, I was in agronomy, got kind of bored after being kind of smart as a freshman, then I got more involved, and I was in the university band. But that was in the band when there was 25,000 people showing up to come and see the band. So I remember what that's like. Now, today's Wisconsin fan thinks it's about winning football, not so much about the band. But we have to keep reminding people, our constituents, our customers out in the state, that they were an integral part of something that's different than 11 o'clock on a bad Saturday or a primetime night game at 6 o'clock. And that's what they think about Madison. Unfortunately, in the media of the world, that's kind of how we are a small amount of things. But bottom line is, we know our importance historically. We love being out here, but then we have to be part of his budget. Whereas I think in agronomy, I don't know how we were, but there wasn't any cost there for us there. So now we're here, and all of a sudden we went, years ago, the university figured out we existed. they were saying, well, what is this WCIA thing on this map in the agronomy? Remember the guys on the board that all of a sudden one day says, who is this? Well, we've been here. You know, we didn't put a sign outside on Linden Drive, like with an arrow. Okay, so anyway, bottom line is we're challenged with this. We're challenged with the times of changing, the importance of certified seed. We do a lot of uncertified things with the lab. We're encouraging those customers. So if you got customers that you know do other seeds kind of thing, you know, send them here, and that helps us. And then when we do a lot of certification for field inspection, and that big number comes in June. So when this budget shows to be, it starts on July 1, but that's when our numbers come in. Those, I always marveled, and we milked cows that you got a milk check every month, maybe even twice. In the seed business, depending on what you're doing, you get it about once a year, right? So, but anyway, that's part of what the board's doing. We're a lot more hands-on helping Sheminder than we were before. So our historical memory is good and maybe bad. Subsequently, we have committee parts, and we're tapping mostly the people here are closer to half our age to be on to those committees. Okay, so look over, and we'll be assigning some tasks within the long range, the education and the certification. And we want to be very creative in what those committees can do, and that'll bring you to the point where us old guys will quit wanting to be on the board, right, Rick? Okay? Which, again, is no different than any other organization I'm involved in. So we're happy for the board. And you guys pretty much know everybody, so we don't have to get up. As I told Randy earlier, we're going to make Randy the chairman of each of those committees. And the efficiency we have is because as a board, as I termed it, we know where all the bodies are buried. Right, Randy? Okay, any other questions of anything? We'll have some time at lunch to think through, look over these numbers. If you want to get us in the corner and ask us where that number came from, please do so. Anything else at this point in business, then we'll turn it over to.
I mean, we did make some accomplishments because when we first started on this, we had 24 months before we would have been flat broke.
Yeah, cash flow has been going,
And
right?
we got it, I think it's up to, last time I figured it out, I think we're around 4 or 5 years now. So it is working, but we've got a big road to hoe to get it to where we can sustain this.
Yeah, so again, in summary, the John with his health issue, and now Sheminder, until she gets that plus what you did before. Accounting wise, we had a full-time accountant since Kate was here, and just so happened Sheminder, by making a few phone calls, and Kate had some health things going on. Kate's back with us. She's working 1 to 2 days a week, doing the same software program that she was before, so she's been here a couple weeks. Shawn, who was our Chong, I pronounce it wrong, no offense.
Nope.
I'm challenged, I can spell any word 6 ways, and now there is 6 ways to spell any word. And subsequently, he's now off our payroll and looking for something closer where he lives, and it's been very helpful in coming back if we have some questions, because he's done it for 5 years. So we've been very good in this transition of looking for more efficiency and helping out with that transition. So, Maynard?
Jack, I'd like to comment a little bit. I volunteered to be on the long range planning committee, and Jack approved that. So I had the opportunity to sit in on these board meetings, and let me tell you, they're doing the best. It's a challenge, there's no doubt about that, but it looks like we're going down the road. There's a straight road, and there's another sign that says dead end. And I guess we've got to look at both ways, because both are possibilities at this point. We've got one big challenge. Our rent is high. Our business cannot support that. So we're looking for ways to increase our earnings, which is hard. As you increase your earnings, proportionately your expenses go up slightly too. So, but they're trying that. And furthermore, the board members have been operating with no per diem, no mileage, on their own time. So I think you owe the board a thank you, because I feel they're doing a good job.
I tend to interject all the time with political statements, and we truly have a board of directors that are statesmen as opposed to politicians. We're here for a reason, because we love this industry, we see the value in this industry, and there is a camaraderie. As I said, we know where all our bodies are buried, but the point is that we're here for the right reasons, as opposed to for all the reasons people get on boards and all that kind of thing. And then some of us are easily close to Madison, and some people just trying to get away from Kewanee. At this point, we're fortunate because two of them can always drive together. And I'm not sure how those conversations go. I only know my own family business. Okay, any other questions in general?
Well, I'd like to thank Maynard for that statement. I think he's 100% right. And I was not gonna run again for the board. I'm 77 years old, and we need some young blood on here. I guess I got put back on, as far as I know. But anyway, thank you. I guess the whole problem is that we had a good amount of money at one time, and we donated or whatever, a good share of that to the university for personnel. And now we are in dire need of money. Everybody is doing everything they can. And we were informed by our director of a few years ago, and there was an awful difference between what he said and what was being done. And we, I guess, were not smart enough. We should have looked into his background. Probably some of it is our own fault, but when you get told one thing and something else gets done and we don't get any paperwork or we don't get any contracts, I think we got led down the road the wrong direction. And now we gotta try and dig a hole and fill the other hole in and get back going again. And as Maynard said, it's gonna be pretty damn tough to do, but I think we can do it. We've got a director now that is trying her damnedest to get us going again, and we've cut expenses. But we've got to have some more meetings, and hopefully Shawn can help us out, or the dean or somebody. But with the money that we've gifted to the university a few years ago, I think we need some help back now, and we've just got to ask for it.
And again, earlier when I defined university, CALS, agronomy, and the Crop Innovation Center, we now as a board understand the differences between all those, where before of us we just thought it was all one, but budgets do divide up people. And subsequently that's what we have to do. And again, we're gifted in the fact that all of us are committed, which then two things. One is we do have a sheet of our incomes. You know, they have that. No, you have that graph. Does everyone have one, or do we can? I think we printed a few off, right? They'll just show you over the year. We don't have to talk about it. It was done in color.
There's someone just outside the door on the table.
Okay, so they're outside on the door table. So you can look at this. A couple of these better years were because of the PPP program.
Yeah.
That's
But
my next
the
political
key is
statement.
they're all below income.
Right.
They're all losses.
Yeah. So anyway, have that so you know that what's in front of us. Then that brings up Peter.
Just for the record, Wisconsin state statute states that Wisconsin Crop Improvement shall be the certified agency for the state of Wisconsin in connection with college of agriculture. Now, I think this is very important. If we go down that dead end, things will change drastically. There will be no more certified seed. For the statute, nobody could go privately and start certifying seeds, that'd be out. We would need no more foundation seed, because there's no certification program. So we need a plan here for new varieties, who's gonna promote them. I think there's gotta be more public agencies that have to be aware of the importance of having this certified seed available to Wisconsin farmers. And we have to get this out through the legislators, we have to get it out through the ag department, so somebody realizes what the consequences are. I don't think anybody realizes what could happen if, in fact, Wisconsin has no certified seed. Very important step, and we have to promote this some way that more people get educated to what's really in reality is going on.
And with that, because we think of small grains, we also are a reach out for the inventions in sweet corn, cucumbers, and potatoes. Schminder and I have been at some meetings, and some of the speakers today will be representing, they have breeding programs, so getting those products licensed and royalties coming back into that research program is important to plant breeding. It's important to those individual programs. It's also very important to our customers and agriculture. So we are a mechanism, because I don't think too many researchers and plant breeders take a lot of marketing classes. They're more intellectually inclined. As one of my friends said, university professors are good for 3 inches wide and 3 miles deep of information, as opposed to how do you bring this to the market. And so anyway, it's a nice collaboration. If we can help that in crop improvement, in reaching out and collecting royalties and getting some new customers, all those kind of things. Is a case in point, our directory is this, but there's equally one this thick for potatoes. Okay, and that's Wisconsin potatoes. So in essence, we're trying to reach out in things totally different than my grandfather started out with Obenbacher barley, a German thing that came out in 1906. So we are what we were. We're having to become what we need to be, and then not forget the things as we go there. With that, we have a board, and we have 3 individuals who agreed to stay on our board. And you got the sheet there. And it's a political season. Does Mark, Rick, or Randy want to give up and give a political speech? No. Do you have any red hats you want to hand out with a big W on it?
Gave my speech.
So anyway, those at this point are the 3 that we've up for election, but we would open the floor for any other nominations. It's really hard to hold you guys back. So, seeing none, then we could entertain a motion to approve.
Motion to approve the candidates.
And is there a second for that?
I'll second.
Motion made and seconded. Any other discussion? I saw 2 fingers coming up, but that wasn't what you were thinking, right, Ryan?
Yeah.
What's that? All those in favor, signify by saying aye.
Aye.
Very good, thank you. And given that, Ryan, just for a moment, you want to get up and tell us about?
Yeah, I'm Ryan Jennison with Impact Systems. Usually work with Dennis Murphy. He couldn't be here today, so I'm filling in for him. I've been with Impact for about 4 years now. Prior to that, I was a city of Madison police officer, so I'm keeping an eye on these 2 here after talking to them all. So
are you acknowledging you know him from a previous life?
I'm keeping score is what I'm doing. No,
Now,
I appreciate you letting me come in and sit in today.
So as a professional gesture, you were the town what?
Constable.
Constable. So did you ever I think you only went after dogs, collecting dogs, right?
That would have been nice.
That would have been nice. So you guys can have a professional exchange.
I got traffic tickets.
Yeah, you got those.
Any warrants though?
Okay, I think we're caught up with the business kind of things. So, we have a gentleman that traveled so very far. How many steps is it?
A lot, yeah.
So our first presenter today will be Dr. Shawn Kaeppler, New Breeding Technologies Applied to Crop Improvement. And by the way, he's in charge of this place, right?
So they say.
Yeah.
Well, thanks for having me here today, and I'm happy to talk about a number of things. I thought I'd give a little bit of a overview on some of the things that we work on and some of the new technologies. We are, come on in.
Waiting.
We work with a number of species who are interested in diversifying the different crops that are available. I am separately connected with Erwin Goldman, Natalia DeLeon, and some other people on thinking about the future of plant breeding at UW and to document more the process of getting seeds and discoveries to growers. So some of the input that you had, as you said, Maynard, is very true that people don't understand what all the steps in the process are as each new administrator comes in, and so hopefully we can provide some information that helps that as well. But like I said, I'm happy to talk about anything today, but I thought I'd start off with a few highlights that I think are kind of interesting and lead into some of the challenges that we have in applying some of these new technologies. So the first one is hemp. Hemp is a species recently deregulated. There was waves of enthusiasm. Everybody knows about the CBD craze that kind of rose and crashed, but there's still a substantial interest in hemp for the fiber, things like hempcrete, paper making, and that sort of thing. And it's difficult to get a new crop into the market because you need both the place that it's going to go, the market for it, as well as enough acres. And one group came through here and says, it's going to take me $1 billion a year to start a stable hemp market because I need, what's the math, like 100,000 acres and pay the farmers $10,000 an acre. And then industry will believe that there's a supply of hemp that's sufficient to make paper or things like that, right? So there's lots of issues with new crops. But this is one of them that we have some funding from USDA as well as some people on campus. Shelby Ellison has funding as well through USDA and other places to try and advance hemp. We were the first group to transform hemp. So this is about 2019 or 2020. This is progenies of hemp. The ones that are orange are the ones that have the transgene that are glowing. Red fluorescent protein, and the green ones are the segregants that are not transgenic. So that was an accomplishment in itself to transform hemp. We've used various markers. This is an example of beet pigment expressed in hemp. We've expressed it in other types of things. You'll see a picture at the end where we're expressing beet pigment and a number of things as a marker gene, but some people have interest in this as ornamental and other sorts of things. But what I'm going to tell you a little bit about today is some of the work that we did working on cannabinoids. And so when we were able to transform hemp, one of the first things we said is, can we make a THC-free line? Which isn't probably a popular objective in medicine overall, but for people growing hemp and having it go hot, it was a big problem to have the possibility that you have any THC in your hemp. And now in Europe, I understand that having zero THC hemp is also either in the process of being legislated or has been decided. There aren't natural varieties that are free of THC. There are some that are high in CBGA, and you can see as I tell my story, another outcome of the process that we did was to produce something that had CBGA, which is another sort of compound like CBD that's supposed to be helpful for your well-being. So if you look at cannabis overall, there's the high THC varieties, they're called type 1, high the type 2 that are CBD and THC. And then what we work with, the hemp, is type 3, which has a low amount of THC and more CBD. And fiber varieties and seed varieties, you don't even have a lot of CBD. Early on, we developed a variety called Badger because it was kind of a wild west of hemp out there, and we wanted to have something that we were working with that was our own variety. It's a pretty good CBD variety. So that's what we do a lot of our work in. When you look at the enzymes that make THC and CBD, they're quite similar to each other. Type 3 doesn't have an active THC synthase, but still makes some THC. And so we realized that was happening because of the inaccuracy of the CBD synthase that was able to make some THC for that particular enzyme. And so our goal was then to knock out the CBD synthase in our type 3 badger cultivar to produce a THC-free hemp. We use gene editing, and you don't have to know all the details, but I just put this up here. With gene editing, we can very precisely land a CRISPR enzyme in the genome. And so we put these guide RNAs into a construct. Out of 3 billion base pairs, it makes it go to that specific spot in the genome and make a change there. So out of our project, we developed 2 types of plants, one that had an insertion that knocked out the CBD gene, and one that had a substantial section of the CBD synthase gene knocked out. When we looked at the outcome of that, we had the wild type plants. The orange is THC. Here we have some CBD and CBDA. You don't have to worry about that. But in our edited plant, we have 0 THC, no CBDA or CBD, and we now have a high amount of CBGA, which itself can have some value. But so we were successful then in producing this 0% THC cultivar. I'll talk a little bit further at the end about regulatory, but now there's this regulatory status review process that you can ask APHIS if your product is regulated in the US. And so we went through this process with the edited hemp, and we were the first hemp, as I understand it, that has, where we produce something that is now not regulated by APHIS. It's said to not be regulated, so it can be grown as a non-GMO product, and we called that line Badger G because it's high in CBDG. And so that's something that we are in the process of, it's available to license to people for various products. And like I said, there's interest in one sector or another, but substantial interest in Europe at the moment, which is kind of interesting. So in ongoing research, we're bulking up seed of this particular hemp. We're able to apply the same technology to make THC-free hemp of other varieties, as well as by breeding. And we're also using transformation editing for other traits like disease resistance, productivity, agronomics, and chemical composition. Yes?
During World War II, in the city of Hartford, there's a hemp plant where they used to make rope for parachutes and stuff that was, and the first plants you showed were the ones that were growing wild in our area, because when we were kids, we used to make forts out of them because you could lay them against a little tree and they'd be pretty much watertight. Were those high in whatever the drugs are in it, or?
They're also low in THC overall. So yeah, Shelby Ellison has been collected a lot of the feral hemp varieties, and so they are low THC varieties.
Because that is a pretty good sized plant. I mean, it's not used anymore, but it was at least a half a block. So a lot of stuff that it goes through there.
Yes, yeah. Wisconsin was one of the biggest producers of hemp. That's why there's substantial interest in hemp in this area, because Wisconsin was a place that had grown a lot of hemp.
And I think they made rope out of it, right?
Yeah, rope at that time I think was the biggest thing. Yeah, no, people are interested in other uses of fiber. Like I said, paper is a big one. Hempcrete in terms of capturing CO2.
It wasn't open in my lifetime. I don't remember it ever being open, but I was born in '54, so.
Yeah.
The building is still there.
That would have been just after the sugar beets that were raised by you, right?
Yeah.
Did you have a question? No. That's good. All right, so that's one project. Like I said, it's quite exciting to be some of the first people to be able to transform hemp and edit hemp and go through this process. One of my goals overall at the center here is to do things in the most elite varieties or relevant varieties and find ways that we can get products out to the public sector. And it's been a challenge overall, not making the products, but getting them so that they can be used by growers. And so it's certainly an interest that we have. So I'll talk a little bit about maize. We have maize breeding and silage programs Natalia DeLeon I work a lot with, and then some of the students and postdocs who worked on this particular project I'll show here. So in this particular case, it's about brown midrib corn, and so this is a corn identified by its brown midrib, but it has a different type of lignin, so it makes it much more digestible for animals. Some of you may have grown or sold brown midrib corn. The pathway is well known. You don't have to remember the pathway, but the figure shows that it is a well-known pathway. Brown midrib 1 and brown midrib 3 are the primary mutants that produce brown midrib corn in the types that are sold for silage. There's other mutants that make this phenotype, but these affect enzymes in the pathway that change the types of lignin that's produced. And the reason that the midribs are brown is because of the precursors that build up. But as many of you know, with brown midrib corn, here I had this article, love it or leave it, there's benefits in terms of that digestibility, but it's also susceptible to lodging. This isn't brown midrib corn, but it's lodged corn. But very often, even the high digestible silage types in our trials are lodged. And it's often more stress tolerant or stress susceptible, because the lignin is also important, for instance, in building the vascular bundles, and it also might not transfer, emit water as well, or other sorts of things. So there's pluses and minuses. It's good for animal feed, but has some agronomic penalty. So our objective was to use gene editing to try and create different types of brown midrib corn. So the top is the non-transgenic or non-edited type. The bottom, you have a strong mutant that has the phenotype that's similar. This is an inbred line called LH244, which is a very good silage inbred line. But one of the things that we found was some interesting weak mutants, and where we could see the midribs were slightly brown, but not as brown as the strong mutants. And we knew, for instance, that the alfalfa product, I think it's called Harv Extra, is due to an intermediate allele, GMO allele, that slightly reduces lignin, but not completely. And so we thought, well, this is a sort of interesting allele that hadn't been seen before and might be useful. Here's the stalks, similar to the leaves. You see kind of an intermediate brown phenotype. And then one of the students, Jose Varela, did a test on the stalk strength. And so you take a piece of stalk and put it in your meter here, and that tells you the amount of force that's required before that breaks. And so he did this flex test and measured the break point of these different types. And the short story is that we had two weak alleles as well as some strong mutant alleles in the wild type. And when we looked at event 1, the weak mutant, it had stalk stiffness that was similar to the wild type. So even though it was brown midrib, the stalks were fairly strong. We think the roots would be stronger as well. And when we looked at digestibility, we saw that the digestibility of this weak mutant allele was more digestible than the wild type. So it seems like we found something where we maybe can improve the standability, the agronomic characteristics of the plant, but still have some improved digestibility. And so just again, a slide that doesn't matter, but here's an example of where our RNAs are. When we had a strong mutant, we had changes that affected the whole protein. With these weak mutants, we had smaller changes. In fact, this weak mutant allele here, event 1, that we think is so promising, had a very unique type of change. So gene editing is very precise, but yet it also offers an array of genetic variation that might not have been seen before and can be useful, and it's very probable that this would also go through regulatory status review and be considered a non-regulated sort of event. So in terms of our ongoing research, one of the things we invented here, my wife Heidi Kaeppler and her team over 18 years identified this gene WOX2A that helps with transformation, so we can transform any inbred line now, and that allows us to make hybrids that are relevant and cross those together to do the experiments versus kind of the lab strains. So we want to take these novel alleles and measure them in hybrids grown in the field for their productivity and agronomics as well as their digestibility overall, to see if this unique allele is something that has value. Rebecca Smith is a new faculty member in the department, hired through the Dairy Innovation Hub. She's interested in the lignin pathway. With these brown midrib alleles, one reason that they are so obvious is that it's the single gene that makes that type of lignin through the whole plant. But we probably want the roots to have normal lignin so it stands up better, and just have the parts that the animals can eat to have the modified lignin. And so she's taking some of these knockouts that we have and then trying to put back lignin just in specific parts of the plant to overcome more of the agronomic barriers that we had that makes the brown midrib corn less of interest to some of the growers.
So,
Yes.
where's your customers for that? And you're selling it to people that are breeding sweet corn, brown midrib corn for silage?
Well,
Cause you're doing inbreds?
we
Is that
do inbreds, and like all of the modifications and companies and stuff are in the inbreds that are then crossed together to the hybrids. Because we can do inbreds that will complement each other, we can make 2 inbreds that have brown midrib types to make a hybrid that can be grown in the field. But in terms of the customers overall, that's what I was saying a little bit at the beginning. It's like, we produce scientific information. There's some companies that have some focus on brown midrib corn, but not as much. The alfalfa is changing.
Because we grow a brown midrib corn silage since 1992, and there's a big difference between the brown midrib corn now and the stuff they grew early on. Early on, it didn't yield as good. It didn't stand very good.
That's right. So the companies who have worked on it are breeding in backgrounds that modify it, and then of course you probably. I don't know exactly, but many people want the Roundup Ready in the other trait packages that are also complicated to get into the final product.
So have you noticed anything when they put Roundup and BT into it, that the plants react differently for feed value? In other words, you got Roundup Ready, brown midrib, and BT, because usually you have to have something to keep the corn borers out of it.
Right. I don't think I have exact isogenic line data on that. But definitely there are issues of plant health and so on that are different when you have
They're
BT,
very
and
susceptible to insects.
that does affect.
Cows like it, and so insects like it too.
That's right. And some of the modifications that help to improve the agronomics are increasing the amount of silica, for instance, in the tissue, and that also somewhat negative in terms of the digestibility or the palatability to the animals to chew on something. So it's a complex sort of process. But
Because years ago, you used to do silage, cobs would all be in the manger.
Mhm.
You don't have any of that with brown midrib.
yes, right. So it changes the lignin in the cobs, and then there's also varietal differences in terms of the cob composition. I had discussions with Mark and Dan about white cobs and red cobs, and if cows like the white cobs better than the red cobs.
Need a white cob before they need a red cob.
Yep. So anyway, that's kind of interesting things, but yes, it's easier to make a discovery than to get something to the farmer, not because only of the science, but because of all the other aspects that go along.
Logistics and everything else.
Yeah. But
That's why I was wondering who your customers were, 'cause
Yeah.
I would assume it'd be like Glycogen and the companies that really push brown midrib.
it could be. I'd be happy to find a path to get it out more broadly to other people as well.
We're
It's
not
the,
plant corn breeding.
yeah, right. So I just wanted to mention one other sort of thing. When you look to the future, people are thinking about what is the next corn going to be, and one of the big issues is the use of nitrogen in corn and nitrogen runoff and nitrous oxides and so on in terms of greenhouse gas emissions. I'm not going to talk very much about this, but we're involved in a big multi-state project in making all the transgenics and edited plants to explore hypotheses of linking, having new corn varieties that fit better into this system so that we minimize nitrogen runoff and maximize nitrogen use efficiency. Some of the goals are to improve early season cold tolerance and vegetative growth of corn. We look at nitrogen running away in the system. Most of it occurs in April and May when there isn't very much vegetative growth. In the middle of the season, plants are accumulating lots of nitrogen. So we'd like to make corn grow like a small grain, for instance, and as well as integrate it with cover crops. Improving nitrogen use efficiency. One of the goals of this project is to reduce the grain protein by 50% and supply better amino acid composition and other sources of amino acids in the animal feed. If you have 50% less protein in the grain, that's where most of the nitrogen is. You're going to need less nitrogen to make that protein. And then other aspects of and recycling in terms of recycling to the root system and novel physiology. So as I said, there's an improved regulatory process that makes it encouraging now that edits can get out there. Genes that were previously deregulated, such as Roundup Ready, are categorically deregulated. There's more clear IP and licensing paths to get things out, and improved consumer acceptance. It's still complex for global commodity crops like corn and soy because not every country is viewing gene editing the same, and if something's going to get on a ship to another country that doesn't want it, it's going to be a problem in the supply chain. But I'll show you an example of where there seems to be more acceptance of GMO for other sorts of crops. And so scientific concerns are really confounded with people's concerns about multinational corporations. We grew this summer. This is Norfolk purple tomatoes. It's a transgenic tomato made in England in 2014. But last year you could buy this for your home garden. So you could buy GMO purple tomatoes, make very nice tomatoes. I grew it, lots of people grew it, gave it to the neighbors. Nobody complained. Maybe they were being nice to me, but there seemed to be very good acceptance of this particular GMO product. But it's the first thing that you could buy as a home gardener. You don't have to sign the Monsanto agreement or Syngenta agreement. Send your $20 in, you get the bag of seeds in the mail. And so this is an example, I think, where there's more and more acceptance of certain types of products. Just said on the package, don't send it over outside the country, right? So I thought that was quite a big advance, and it's a very tasty tomato. Can't remember if I brought some down to you guys or not. And APHIS is getting more and more friendly towards certain things, improving the flexibilities and how developers can use biotechnology for things that could be achieved through conventional breeding, as well as they just recently increased the number of modifications that can be in a plant and have it be categorically called not regulated. So there's more and more of a path in the US to have a range of products that are not regulated. And like some of my examples, we can make some really interesting things that I think could be useful to people. The whole process of this, there is more IP and stewardship and compliance concerns. And for that reason, I think setting up some system where there's a better connection between the public and privates, not just the multinationals in the public sector, but groups like you that sell seed, to find the paths to get these really interesting products out there is something that we should consider for the future. Having completely unrestricted release of nearly any cultivar that has substantial value is just much more complicated these days, whether it's transgenic or edited or not. There just is more things to consider. So I hope we can find paths to get some of these really interesting things out to people who can use them. So thank you for your time. This is beet pigment and corn seeds, and this is an editing project where we're turning yellow seeds white. So that's one of my favorite little pictures. Yes?
A few years ago, we were playing around with a Mexican corn that got about 20 feet tall.
Yes.
And everybody's talked or heard about the nitrogen fixing, the sap dripping off of the race ruts.
Yes.
As soon as you back crossed that or tried to put another line on it, the first thing that disappeared was the race ruts with the sap dripping off of it, or the nitrogen liquid.
Mm-hmm.
Is there much progress in the plant breeding to try and locate that gene? Or I know we all hear about people coming out with nitrogen fixing corn. Well, is there a different way that they can locate that gene?
So there's an array of things, and it is one possible path to having some nitrogen fixation in corn. When the reason that corn was very tall was because it was photoperiod sensitive, and so we have equatorial corn here. We work on things from Guatemala and El Salvador and so on, We put them in our blackout greenhouses, so they only have 12 hours of light. And then they grow almost like normal corn. And when they have that photoperiod response, then they often make many more roots. So there's things that I've brought from Mexico and grown here, and they have many, many nodes of aerial roots, when in Mexico they look just like a normal corn inbred in a short days. So some of what you observed there was the photoperiod connection. But there are genes that affect the number of brace roots, and when that first report came out, everybody was sending in pictures of their hybrids grown in the field that were dripping mucilage at some point in time. But in Wisconsin, it's not like the place in Mexico where that corn was grown. That dries up very quickly, so very rapidly you have these aerial roots that just have little dry pieces of mucilage on there. So there's a relatively small amount of time that the nitrogen fixation can occur. The other part is that you need nitrogen to build that plant to get to that size. When it's dripping, mucilage is usually at the point where pollination has occurred, but you don't have a lot of pull into the seeds of the sugar. And so it's pumping that sugar out of the roots as another place to go, right? And so you need nitrogen to get to that point to have that big of a plant. So you might find benefits, and I'm involved in some projects in some way. Jean-Michel is the biggest one in centralizing this, but trying to introgress this trait into our varieties, and you might get some benefit in the middle of the season when it is beneficial because you're not side dressing or something when the corn is very big. But that particular trait is probably not likely to make all of the nitrogen that a corn plant needs to yield 300 bushels of nitrogen.
Well, there was brace ruts 6 feet high. So
Yes.
we should have covered that corn for only having 12 hours of daylight then?
Well, that's one of the things, when you get this maladaptation response of growing a short day adapted type in long days, you'll get these very tall plants that have more nodes, and it's a juvenility trait. Yeah, there's other, we've edited some things, and they have brace roots for a company, brace roots all the way up to the top of the plant. Yeah. But yes, there is fundamentally hope that various strategies will improve the nitrogen fixation and certainly the nitrogen utilization in corn. Yes?
Yeah, Shawn, you had that picture, the photo of, I think it was a beet marker or something in the
Yes, yeah.
beginning. Can you put other colors in hemp? They could replace poinsettias at Christmas time for the ornamental guys.
Yeah.
I mean, if you could put red or something else in there. I mean, you had them in the fluorescent pictures, but then you'd have to have a black light to notice them, I guess.
That's right, yeah. So anthocyanins is another thing we're putting in there, and there are ways to get different shades of anthocyanins. Yeah, the fluorescent ones, the fluorescent proteins, we use a light that they sell for tropical fish tanks because tropical fish glow. So you just put a red sheet out and then put this tropical fish light on, and then you can see the plants glowing. But there is also another cassette of genes that make the plants glow on their own. You can buy these glowing petunias now. They don't really glow very bright. You have to go at the right time of the night, take a picture of your cell phone. But yes, so there are an array of things that you can put into plants, and they're fun because people can see them. Thank you.
And if you get the right hemp and you smoke enough of that, then you can see the lights anytime. Well, that's when I went to school here. I couldn't understand as a farm kid why everybody was, but I was here during the TA strikes and all that kind of stuff.
Yeah, you mentioned the ditchweed, right? When I worked at the University of Nebraska, the corn breeder there, so I can document that's not useful weed. I smoked it, and don't bother.
Well, very good, and you're going to be with us the rest of the day, so if you have a private consultation you want on hemp.
Yes, I'm happy to talk about any hemp or any of the related topics. Yes.
Okay, very, very good.
Speaking of hemp, do you get samples of hemp seed at the lab? Does Schminder get samples?
Hemp? Yes, we do.
Of hemp samples?
Mhm.
And what is normal germination on hemp? Do they
It
get
depends.
pretty good?
Most of them between 80 to 90% germination.
Okay.
Sometimes they're bad, but mostly above 80%.
Okay. But you can't check THC
No,
levels in seeds,
not
right?
here, no.
And you think there's a market that it's a growing thing, or do you think it's sort of dead?
There was a few years ago, but now it's going down. We did inspect few fields, but not anymore, like 3 or 4 years ago. People were trying to certify.
Yeah, and again, replacing paper, and there's a lot of cloth now it's made out of it.
Mhm.
And anybody know the name Steve Goff? He was very, very involved in cover crops in Pennsylvania.
Mhm.
So this morning on my Facebook, he traveled over there, and he was at a textile mill, and they're doing hemp fabric. And he's exporting a container of hemp over there to get it manufactured. I'm not sure how the tariffs work on that, but there's some opportunity there. So the bottom line is you gotta replace a deep tradition of trees with something, and Declaration of Independence was written on hemp, right? And it's still in that case someplace in Washington DC. So there's some opportunity there, but it's kind of slow to get to places, and you gotta, as you said, $1 billion to take out all of that stuff to make it something you can have, so.
Yeah, once it can be a commodity, then
That's
people
right.
will find things to do with it, but
And,
it's how do you
once
get
it's a
that?
commodity, which means is, how can I get it to no cost? We fight that every day, certified seed or saved seed in a gravity bin, right? So anyway, that's not a good introduction for our oat, but I just looked up and said, what did I just say? Anyway, our next presenter, Lucia, is our talking about planted, but she's actually from, and maybe agronomy was a lot easier to remember.
Yes.
The new name, so I won't ask you, how did that committee, or what bar did you guys go to come up with your new name?
Committee is the key term there. It was the least objectionable combination of words, yes. Pass. P-A-S, pass.
You got it, you got it.
Excuse me again.
Yep. Fellow Louisian, Lodi, what do they call you from Lodi?
Blue Devils.
Well, I know that, but what would be the, like, are you a Loedian?
I'm a transplant, so
Oh,
don't
you-
ask me.
Or you just live there? Right?
I'm from way up north.
Got it. I have a Lodi address now too, so. But that was
Yeah.
based on
I
grandsons.
got the letter in the mail.
Yeah. Yeah, they told you I existed up there? But he's up by Gibraltar Rock.
No, it should work.
A couple cases in point, again, historical memory. Back in the
Mark?
70s, I had a variety of corn that was very, very stiff stalked. Never lodged at all. But if you send it out to Iowa where the wind blows all the time, it green snaps. And green snapping is when the plant breaks off below the ear. Not a good characteristic in a summer storm. So when we used to, in FFA, we used to sharpen chisels and temper it. So you can get too strong and it snaps over. You want some weeping.
Oh, don't worry.
Ready?
Yeah?
There you go.
Okay, good morning. So just one housekeeping question.
Sure.
Do I still have the full time or
Yes.
should I keep it short?
Yeah, yeah,
Okay,
we'll just,
okay.
I'll try to talk less.
No, no.
I need to
that's
eat
fine.
less, so I'll go into dinner time if we need to.
Good. So thank you very much. It's great to be here again with this group. And I was asked to talk a little bit about the updates in our breeding program. So I'm gonna go through some of those updates, not everything. But in our breeding program, so the goal is to contribute to the sustainability of the cropping systems by having varieties that are adapted and that are good yielding and disease resistant. So to quote Shawn, instead of making corn behave like a small grain, we're making small grains do what they are supposed to do, which is contribute to the sustainability of the cropping systems. So So, and I'm gonna talk today about oats and wheat and what we have been working on that, but mainly on the breeding aspects. So way more applied and translational than this morning's talk. So first with oat, we'll know the market classes for oat. Oats are being grown for food, and there is a growing demand for food oats. In the US, we're not seeing that from US source oats, but worldwide there is an increase in the demand for food oats because they are healthy, because they are because of the nutritional value, because of the value in the crop rotations, because they are good alternative as plant-based. So there is a very strong interest in that. But for us, the main markets are for feed or for forage. And so we're gonna talk a little bit about both of those. Feed, we're still producing grain. For forage, we're producing haylage. And things that are important, performance is very important, but other considerations such as lodging and disease resistance are very important in the breeding programs. So this is a list of goals that we have in our breeding program, and it's not just a single trait. And that's the thing, when we're producing variety that needs to be performing for the farmer, that means that we need all of the traits, right? We cannot go with just one single trait or event. So that means that we need grain yield, otherwise no one is gonna grow it, right? In oats, we need crown rust disease resistance, because even when we can apply fungicides, we have a yield penalty when we do have the disease. We have had a few years, very dry, where disease was not so important, the crown rust. This year was still very important, but this is something that is very important. Maturity is also very important, so when it is ready, when it's heading. Lodging, if it lodges, it depends on the time that it lodges. If it is very late, we can still pick it up with most of the combines and we don't have tons of yield penalty. But if it is early enough, and it stays there, then what happens is we start to have yield losses and other problems with the quality of the seed. Plant height is still relevant. Is not the deal breaker. There is a little bit of an association between height and lodging, but there's not complete association. Lodging happens for other reasons besides height. The taller the plant, the higher the grain yield you're gonna have in general, because all of those are associated. But then if you risk lodging, then that's a problem, right? So usually we try to strive for something not so tall. And then there are other diseases besides the crown rust that are important in the breeding program, which is, especially in the south part of Wisconsin, is valley yellow dwarf virus, and that extends to Illinois and the south. Not so important in the northern area. Stripe rust is also coming, and we're seeing more stripe rust, and that's also relevant. For the grain varieties, we also care about test weight, and that's the weight of a volume, and that means that if I pack a truck load, how much grain can I pack there in that truck? And so it's very relevant because of that logistical issues. Plump grain, we want them plump, nice and plump. We also want beta-glucan content and avenantramides and other properties that have proven to be healthy. So those are traits that are desirable in the grain varieties. In the forage varieties, because we're harvesting them at booting, that means that the grain traits are not so relevant other than the incipient grains growing inside the boot. So the most important traits have to do with biomass yield, milk equivalent yield, and forage quality. And we're gonna talk a little bit more about the difference between those by the end of the talk, because I think that those are quite relevant for this group. So this is a traditional plum breeding, how it was done when I came. Basically, we start by making a cross between two lines. These are pure lines. We do about 100 to 150 of those every year, and then we have about 20,000 genotypes in the segregating population. So the F1, and then we have the segregating population in the F2, and then we grow about 1,500 plots with F3 families and about 1,500 F4s, F5s, F6, And at this time is when they start to be more stable genetically, and that's when we can do yield trials. So we harvest them in bulk, and we have about this 4,000 to 8,000 yield plots. And so this means that in a year we usually evaluate about 15,000 plots to be able to screen and decide which ones are the best. So it's a lengthy process. And this is very classic way of doing, and then the yield trials. This is how we got it, and I'm gonna talk a little bit about the modifications we did and things that we have improved on that process. So this means that all of this takes about 12 to 14 years to release a variety, right, in a classic breeding program. So these are just numbers on the different generations and that we have used in our program throughout time. And these are just pictures of crosses we make in the greenhouse. This is just an aerial picture. I don't know what's going on with the pictures. Aerial picture of the hedgerows in the field and the F2s. So these are our nurseries. These are at West Madison, at the West Madison Agricultural Research Station, just over here. And usually at the field days, we don't see them, but I'm happy to host people if they want to see all the breeding program, all the steps of the breeding program, and not just the last steps that we see at the Arlington field days. So these are more pictures of the nurseries in the greenhouse. Oats is a little bit tricky, a little bit more trickier than wheat and barley to make process. So here are some of the things that we have been thinking about on this process. One is we want to accelerate it, right? 12 to 14 years is a lot. And so to accelerate that breeding process, we have thought about different strategies. One of those is what we call, what is called speed breeding. So you're probably very familiar with double haploids. This is a way where we can do agriculture, and then by doing that, immediately we get a stable, pure line, right? So that's one way of going from a cross to an immediate pure line. But in oats, they didn't work, right? They were very genotype specific and they didn't work. So we have to think about other ways of going fast from that, all of those nurseries that I show you, we needed 6 years to get from the cross to stable lines. So how can we get there faster? And one of those is what's called speed breeding. And this is a fancy name for an old trick, old physiology, where we're just growing the plants with longer photoperiod, so more hours of light in the greenhouse. That means that they are a little bit more stressed. We also grow them at higher temperature. So we stress them, so they like to go and set seed faster. So they like to head sooner and have a shorter cycle. We do provide by having more nutrients and better nutrient management so that they don't go completely stressed and shut down and don't produce any seed. But by doing that, we were able to grow an oat that loves the greenhouse. Instead of in 111 days, we were able to get them in 80 days. So that means a lot of time saving. And that means that now we can do this speed breeding in the winter time when we cannot have the plants in the field and advance our generations. And so with that, we have we did that and we have decreased the time to a third. And then we also increase our cross efficiency. So we work on optimizing a little bit more how to do cross efficiency by having more moisture and a few other things in our program. So we decrease the time by doing this speed breeding in the greenhouse, right? The other way that we have done decreasing the time is by using what's called genomic selection. And this is, we use DNA information, so marker data. We usually use either a whole genome sequencing or a chip that we can get. We genotype every line, and then we use some fancy statistics to predict the performance of each line. So we can know. It's like similar to when you do marker-assisted selection where you identify the gene and then you say, okay, does it have this allele or that one? But for these complex traits, it's not just one gene that is very important. Grain yield is hundreds of genes. So instead of doing that for one gene, we do it for multiple throughout the genome, and we get predictions. And we get very good predictions. So now what we have done is in those speed breeding strategies in the greenhouse, we have started implementing genomic selection. That means that, for example, this week we're harvesting the F4s that we have. We planted those F4s that were previously in the field, and then we grew them fast, we genotyped them, and we predicted them, and we're selecting them and harvesting them to go into F5s. So that means that the speed with the greenhouse, by doing the speed breeding with a genomic prediction, we increase the efficiency by 3. That's impressive. So that means time reduction from when we make a cross to when we release a variety. And that means that we're moving faster, so hopefully we're getting better varieties sooner to all of you. So other things that we have done is we have worked on improving the phenotyping or the efficiency, because we spend, as in the US, we spend billions of dollars in evaluating the possible lines or varieties before they can be released in breeding, right? In our program, we don't spend billions, we spend thousands of dollars evaluating those. And one of the things that was done when I came was that we evaluated every single genotype in every single location, and with 4 replications. That meant that by having my 6 to 8 locations, I could evaluate 20 genotypes with a huge effort on everyone and all the collaborators. That was a lot of money spent on evaluating those 20, so I had to be sure that those 20 were really good, right? So instead of doing that, what we have done is work on some experimental design optimization, meaning that we did billions of simulations to figure out better ways of doing that. And it ended up being that we don't need to evaluate every genotype in every location, because some locations have similar rankings. So that means that if they have similar rankings between the 2 locations, then I can evaluate it in one of those. And then by using all the genomic information, then I can have a very good idea of which ones are the top performing. So after doing those billion simulations, we came up with this idea of what we call the mega environmental experimental design. And that, when we look at the response to selection, it increased the response to selection about 40%. So again, we're doing a lot of things to help us in our breeding so that we can be more efficient in how we evaluate the lines and get them faster out of the door. So this was one, improving the efficiency. Other things that we're doing, and this is a more recent project, so I don't have tons of data yet, but we're using also drones and other AI in our breeding program. So we're flying the drones consistently in all the trials, not in all the trials, in the West Madison trials and in some of the Arlington trials. And then what we're doing is we're using the drones again to help us in predicting this performance, to help us identifying which ones are the best. In our nurseries, I told you we had about 8,000 plots, and we used to score every single plot for heading date. With the drones, we can help in doing that, and that means that, in half an hour we get the data, and people are in the AC doing that instead of having to walk the field with a lot of people. So those are things that, again, helping us understand a little bit more on which one of those varieties are gonna perform better. And other things that we have worked on is this panicle and grain architecture. And this is more related with food grade, right? Eventually, in our program, we would like to have very good food grade oats. And that's aspirational for all the breeding programs in the US. We would like to have more of the food grain oats sourced from the US instead of Canada. And so we're all working together to be able to get there so that we can get to the farmers a variety that is gonna consistently produce a food grade oat so that the industry can pay a premium for those and the farmer can actually grow it. But for that, we need a lot of things, right? And some of those have to do with the grain size of the oats. And when we have, especially when we have crown rust, some of the diseases or other stresses, the grain tends to be smaller and shrunk, not so plump, right? And so being able to understand this grain size is very important. So the other thing about the oats, and you're probably very familiar with the oats, this is an oat panicle, right? And some of those spikelets, they are called this little things hanging. Those spikelets can have either 2 grains, 3 grains, or 1 grain, right? And how does the panicle decide which one is gonna be 1, 2, or 3 grains? It has to do a little bit of resource distribution. So throughout the panicle, you have more of the one type or the other one. But then most of them will have 2, and that means that when you look at the grain distribution out of the combine, you see this bimodal distribution. So this means that some grains are on the large side and some grains are on the medium side or the small side. So as a breeder, one thing that I would love to is to have everyone on the big size, right? So that's one thing. So we were wondering if this was genetic, right? If we had this, because some of them will only have one distribution. So would it be something we can select on, one trait, one gene that we could select on for the distribution of the grain size? Because this will give more uniformity to the industry, and that means that de-hulling efficiency increases because they are more of the similar size. So one question was, can we go to something more unimodal? The other question was, or maybe, you know, the third grain in this that have 3 grains, the third grain usually is so small that it's blown out in the combine when we harvest. But the oat put a lot of resources into making that third grain, right? So the question is, could we fill it into a full-size grain that is gonna yield higher? And that means, you know, like we did in with barley or wheat, is having more full grains out of each one of those spikelets. So what we did is, we did some image analysis. We scanned thousands of oat panicles out of thousands of genotypes, and we evaluated a lot of things. Some that had to do with the shape of the panicle, because we didn't know if shapes like this one, we're gonna have more of the 2 grains instead of the 1 grains, or, you know, more compact panicles, we're gonna have something like that. And then we also scanned the grains. And then what we found is that, yes, there is a very strong genotypic effect. So we can select on that. And we're actually selecting on that. In those genomic prediction models that I told you, even before we have a large amount of grain, we're actually selecting on the grain size with the predictions for the new varieties. So we can do that. Regarding the filling the third grain, I'm still on the fence, and we will see. We are having some new experiments where we're actually trying to make crosses and figure out what's going on with that third grain. It has to do a lot with environment. So we think that what's going on is that some genotypes, in a good environment, they will fill 3 good grains. And this is true for maybe these 2 sample genotypes that I'm gonna describe. They both fill a third grain that is decent, that is retained out of the combine. But what happens is that under stress, for example, drought stress, one of those genotypes shuts down and says, I'm not gonna fill. I'm not gonna try to fill my third grain, and only fills 2 that are very heavy. But the other genotype still attempts to fill the third one. And that comes with a penalty, because when it tries to do that, everything shifts down and all the grains are lighter. And we have seen that consistently in our data, so we have done some experiments with the drought to actually impose the drought to look and study that. And it is genotype specific. That means that, yes, we can select on those. And we don't want those. We don't want the one that risks the filling the grain and then fails, right? We want the one that senses environment very soon and decides to fill 2 grains that are very full. That means that physiologically there are a lot of consequences of, who is determining the grain field in oats. But that's something that we are exploring more, and we have already the predictions for actually using that in our breeding program. So those F4s I told you we are harvesting this week, they were also selected based on this, based on the grain sizes, so that the grain sizes of next varieties are going to be larger and heavier. So, other things, because when we grow the plants, we have what's called the genotype by environment interaction. We grow 2 genotypes in one environment, and this genotype is the best, right? And then we go to another environment, maybe another location, and what happens is that the other genotype is the one that is the best. And that's a problem, right? Because that means that I'm not going to be able to have an oat variety that is going to do well across all the environments in Wisconsin, not even in Wisconsin. Of course, not in the US, right? That means that we need to be careful, and we need to understand what's going on with these changes in the ranking for our recommendations. And initially when I came, I thought it was north and south, the way it was managed, but we figured out that it was not north and south. So that means a lot of things, right? One of the things that it means is that, okay, I cannot just grow them in Madison, decide, select in Madison, and then try to force it into all your fields, because it's not going to work, right? Because the ones that do well in Madison are not necessarily the ones that are going to do well in your fields. So that's one consequence. That means that I need a lot of testing. That means a lot of effort into actually putting them into the field in different locations and evaluating them. And this is my network of trials. So in Wisconsin, these are the trials. Some of them we haven't used in the last 2 years, but these are the set of locations that we have in Wisconsin. And then after doing the evaluations of the initial phases in Wisconsin, the top varieties or the top lines that could be varieties, we send them out to what's called an MCON, a Midwest Collaborative Network or nursery that we created with the oat breeders in where Wisconsin, Minnesota, South Dakota, North Dakota. And there we are testing them at 8 locations for 10 genotypes of each one of our programs. So we get early testing by collaborating with them. And then we test them in what's called a uniform oat performance nursery, and this is a network of more than 20 locations in the northern US and Canada. And there we have about 3 genotypes that we can send every year, and we test them before we make a recommendation to all of you. So those are just some of the pictures from the multi-environment trials in the different locations. But then the other thing that we did is, okay, can we know which ones are those regions where I have these changes in the ranking? Because initially I thought it was north-south, but it's not. So can we actually know and study that? So what we did is we're using big data. So this means that we're using thousands of data points or millions of data points actually to try to understand how the rankings change in our growing areas, so that I can make a recommendation of, okay, these oats are going to be good in this area, but these other varieties are going to do better in this other area. And what happened when we looked at that, if you look at Wisconsin here, we do have mainly 2 groups of this, what we call mega environments, which are these 2 groups of where the ranking changes. So that means that, yes, some of the suspicions that, yes, the varieties that are best here might not be the ones that are best there is very important. That means that we have decided to change a few things. One is we added a few locations right in this area because we didn't have those. But also that means that we are starting to think about recommendations, different recommendations for the different areas. That means that we're not going to have just one variety that is going to do well all over. And you have seen that. For people who are close to Spooner, they always, for years they came and said, but they don't work, right? And I was like, yeah, but. So now we have figured it out, right? In Spooner, which is more drought prone, we need taller varieties because the short varieties tend to get too stunt and then they don't yield anything. So we need taller varieties, and they don't lodge as much because they have more drought problems. And so those type of things is what this type of data is helping us. And for this, we looked at 5,000 genotypes across 59 locations in 9 states and over 25 years with marker, with genomic data to try to understand a little bit more how this works. So all of this, we're putting it to the service of getting this for the breeding program, these predictions and getting better varieties. We also put it in what we call a variety decision tool or a variety selector tool. And this is when you enter your zip code, what you can get is you can get a ranking of the top varieties for your area. And that way it can help you in selecting which ones are the best varieties for your area. For the farmers, we're also implementing this behind the scenes for the breeders so that we can say, okay, which ones are the ones that are going to be best and which ones are the ones I need to use as parents in my next crosses instead of going blind on doing that. So these are things that we have also worked and actually using them in the breeding program, right? Finally, resilience and stability, because, okay, we have the location effect, which is very important, but you all know that year-to-year variability are impressive. They're really, really, really strong. And then that means that, okay, we have a year that it was dry, and I told you taller varieties tend to do better when it is dry. Or we have a year like this one when it was dry, and then it was wet, and depending on when you planted and where you were, you experience more of one or the other one. But then year to year, we're never going to be able to control it, right? Location, okay, your farm is here, you know which ones of this to plant. So we're going to need varieties that are more stable or resilient to this, right? So that they don't completely fade if the year is a bad year. So what we have done is we have looked at data for, so this is barley, oat, and wheat, and we're looking at resilience and stability. And at first I was a very, very, not even agnostic. I think it was against stability. I was concerned that, you always had this image that, oh yes, you get stable, but it's the lowest yielding. So it's always going to be bad, right? So those we never want in a breeding program. So what we looked at, the mean and the stability, and you can see that, okay, it's not like that. It's not that if you get a stable genotype, it's always the lowest yielding. You can actually have some genotypes that are very stable and then very high yielding. So what we did is we tried to identify the genes that are responsible for that stability, for year-to-year variability, and then you don't need to worry about this, but we also did predictions. And what happened with the predictions is that we get a very good ability to actually have an idea of which one are the best varieties when we do this. So this we're also using in our breeding program. So that's for the jargon on what we're doing all behind the scenes before we get to the varieties, or in order to get to the top varieties. So what are our oat varieties? So this is a release timeline for the grain oat varieties, and this is for the forage oat varieties. And so, about every other year we release one or the other of grain or forage varieties. So we have been more constant at releasing varieties since I started over there. A few of those varieties, Escar 2020, it was a very good variety. It was released in 2020 as a high yielding oat. and that was meant to replace Esker. Esker, one of the things that it had was that it was quite stable. So, so we wanted to replace it with a variety that was stable, and then that's seed sales of Esker and Esker 2020, comparing one to the other one. It's not the top for test weight. It's not the top test weight, but it's a very good agronomic variety. Oops. Huh. Okay. So Antigua got lost somewhere there. So we also have Antigua. I don't know what happened to that one. Antigua is one variety that was one of the first ones I released, and it has a small grain. That means that in the Dakotas, it produces too many thins. In Wisconsin, most of the time it's okay. It's a very good one for feed because of it's the heaviest test weight, and it's still the heaviest test weight that we have in the trials. So it's still very good for feed. And then the other thing that it's very good for is as a cover crop, because the seed is actually cheaper if you plant by seed count, because one bag will have more seeds, about 30% more seeds than the other varieties. So it's a variety that they really love for cover crop also. So for the performance of this year, so we had an early season that was dry and hot, and then a wet, late season that was wet, and we had a lot of crown grass disease and a lot of lodging. We almost, some of the experiments, we have very mediocre yields because of the lodging, because of the heavy storms that we had at the end of the season. So, okay, what's going on here? Okay, I'm missing one of the slides with the actual data. I'm gonna find it in a second, but I'm gonna tell you that you probably saw the report, the variety report. What we have is this year we had some of the lines were not so exceptional in most of the locations, but we have some of the advanced lines that are ready for release or almost ready for release that did amazing. The yields were all over the moon in all of those, and I'm gonna get you that in a second. Probably 5 minutes. But that means that we have very good materials, and we will need to make a decision. I put there 3 of the varieties that we think are very good throughout the different locations, but we can have a conversation of which one of those should be released. They have been, we have done a mini increase with foundation seed. They don't have enough to go this year, so we'll need to grow it. But we'll need to decide which one of those 3, because their foundation is hoping to minimize risk, and so they only want to increase or do a large increase of the one that we're actually releasing. So that means that we're waiting 1 more year for that. So, so we need to make that decision before the next season. And I promise I'm going to put it out there in a second. So for the forage oat, these are some of the results, and I know it's tiny. It's in the publication, so you can have it there. What we have is we also added a few lines that have been doing pretty decent. So one of the things that I think we have always been at this conversation, and it took me a while to figure out the different goals that people have in the room. So Forage Plus is a variety that has a high dry biomass, and that's the peculiar thing about what Forage Plus was, right? Then the relative forage quality is not particularly exceptional, and the milk production is not particularly exceptional. So biomass, how much? If you're selling your haylage, then biomass is very important, right? If you're using the haylage in your farm, you do care about how much yield that haylage is going to give you, right? So milk production is the other trait that is important. So 2 of the varieties that we released, Laker and George, were specifically designed to produce more milk production. So that's a dichotomy. We can have, and we should have both, right? So some of the newer, some of the varieties that we think could be good. In Madison, you can see that they are on the top for biomass and on the top for milk. In Arlington, they are on the top list for biomass, and some of them are higher than Forage Plus, but they are average for milk production. So we would like to do both, but there is always a compromise, right, there, and that has to do with when we have them or when we harvest them and how they grow, right, and the quality of the feed. So Forage Plus, we talked about it. George, we talked about it. It's a very good variety, again, especially for milk yield. So this is a conversation I think we need to have, which is, do we want higher biomass or do we want higher milk, or which ones of those traits are more important? For a lot of you, this is more important, and that's why it was so hard to replace Forage Plus. For some of you, this is more important, and I think George has a place there. But the newer varieties will have a place in both of those. This is just an explanation of some of those. So this is done, it was done a few years back. I don't know what's going on with the images. So this is the relative forage quality on growing degree days. As the crop matures, the forage quality goes down, right? So that's known, very well known. So the later you harvest, the less quality you're gonna have. But the biomass goes up, right? As you go later from, this is booting and this is heading. As you go later, the biomass is gonna go higher. So then that means that there's a compromise there on how late you wanna harvest. Most of you, I think, are interested in harvesting at booting. So we're looking at this area here, which was the other thing that Laker was released because we could harvest it later, but at the same time as Forage Plus and still have a very good yield. But if this is our space that we're interested in, then what we need to look at, and then we have that, this is milk production, right? So then you can have milk, and then this is the forage biomass. So, important to know so that we can actually decide on which one of those. So for those, again, these varieties or these lines that we could be working with, milk production here is top of the line. They are the top performers for milk in this year, but also 3-year average. Then in biomass, they are pretty high. We don't have stars here because we had a problem with one of the data points of Forage Plus in Madison. So we don't have stars here, but you can see the numbers that are pretty high. In Arlington, the story is a little bit different. They are top performing in biomass, not so necessary in milk. That means a lot of things. That means that we also need, remember that genotype by environment interaction, and I have 8 locations for my grain trials. We only have 2 for the forage. So what we're thinking is that we need more locations for the forage so that we can actually, because I don't know if your farm is gonna be more like this or more like this or something else. So we need to test it at more locations. And so we've been having conversations with some of you about being able to grow some of these forage trials with not the whole thing with hundreds of genotypes that we have here in West Madison and Arlington, but maybe with the top or some of the ones we think could be good, having them grow out there so that we can have an idea of which one of those are going to perform better at your locations. So that's for the forage. So
do you have disease ratings out of them too, or?
Yeah, we do disease ratings. Forage Plus is full of crown rust. You already know that. It's one of the reasons we think it needs to be replaced. And some crown rust, it starts right there when you're harvesting, right? But for seed, it's a real drag. So it's very important. We do disease rating on all of them, and we also evaluate the grain yield because it's going to be seed yield. That is another trait that is very important for seed production.
Do you publish that, the disease ratings on them? In
We
the forage trials, or?
haven't, but do you want to add it, Martin? We can add them easily because we have them. Yeah, we do scoring on all of them. So we can add them. We can add the scores the same as we do for the grain varieties. Yeah.
Okay.
Yeah, we can have a table like the table 1 or 2 in the report for the forage varieties.
Okay.
Yeah.
And you evaluate them if they're leafy or like a stemmy plant? Like Goliath is just a stemmy plant with no leaf.
It's a monster, right?
Yes.
Like that's a name, right?
Yeah.
So we do a visual evaluation. We don't actually do a scoring on leafiness, but it's one of the traits that we use to decide on whether we move them to the forage trials or not, even if they were not forage crosses.
So you're picking more leafy ones?
Yeah,
or
more leafy ones.
more leafy ones?
Yeah, like forage
Forage
plus.
Plus always had a
It's-
really big
yeah.
leaf.
Yeah, that's the main thing.
And the Goliath looks good, but once you actually get into it and harvest the field, there's not that much there.
Yeah.
So.
Yeah, so we think some of those other varieties are better than Goliath, and Goliath is also a lot of disease problems.
How does George compare, or rust ratings compared to Forge One?
Rust? Oh, it's way lower. It's now starting to get some rust because most of the varieties, as time passes, they get more. But it was one of the reasons. Yeah, George is way lower than Forage Plus. Yeah. Yeah. Good. Other questions or comments? Okay. So then, a few thoughts on forage. So we think that we need to focus a little bit more on forage, and that was because there is more interest right now with Forage Plus having all those problems. So one is these traits, and I do want to have your opinions, your ideas on biomass versus milk, and of course both, but which one is the top driver? And I know I have thought a lot about milk in the past when I was releasing some of those varieties, and now I'm focusing more on biomass because that's what I heard is really important. The other thing is we always plant them in the spring, but some of the farmers will plant them in the fall as a forage, not for seed production, but as a forage. And so do we need evaluations in the fall? And that's a question that I think is important for this group is, should I have some trials planted in the fall where we evaluate forage in the fall? Because it could grow different, because some of these are sensitive to photoperiod. That means that they respond a little bit different when the days are getting longer than when the days are getting shorter. And so do we need those trials? It's one question for you. And then the other question is, some of you are growing them in a combination with peas. So do we need to put them in intercropping? And so one of the things is we are going to be working in the next month and 2 months, so December and January, on trying to figure out all of this, what are the most important questions, and coming up with a plan so that we can have it ready before planting season and do those evaluations. So Martin is working on that proposal, and I haven't introduced Martin, but I'm going to do that in a few minutes. So that's for oats. I don't know, questions or comments? Yeah.
I'll just throw this question out there because I genuinely don't know. Has anybody ever done an annual clover or a perennial clover with oats, like at a very low rate? I was always kind of curious why it was always spring peas that was paired with oats.
So I think that the system is whatever works for the people working in that area. Yes, oat has been used as a nursing crop for clover. Yes, that's very common way of using oats as a nursing crop for clover,
Not just that
alfalfa,
regard,
and
but like when you're talking about intercropping, somebody's like, well, I want to have something other than oats and I want to lob it off. Let's put spring peas in there. And I was just curious if there was anything looked at, like if somebody threw a burr seed or a crimson in there.
Yeah, and yeah.
We put alfalfa in.
Yeah, and you put alfalfa. Yeah, yeah. So, is your suggestion to try a few of them?
Perhaps.
Yeah, I think that would be fantastic. I mean, we're working in collaboration with other groups in the U.S. that are working at intercropping and breeding for intercropping, and those were thought of. Some of those, so clover, alfalfa, of course, and yeah, not crimson. Yeah, yeah. Good, great comment. Yep.
You had a slide there with the 4-H Plus, and there were 3 experimentals. I assume the certification committee will be looking into them. Right now, I don't know, there's nothing published as far as, you know, you had it up there. Is that available?
Yeah, sorry, this is being published, so we always publish by Halloween, and so do you have the link, Shminder, for the reports? So we moved them from they're no longer at Cool Beans webpage, but that has been for several years. We moved them to do you remember, Martina, off the top of your head, the cereals variety testing?
Is that all the small grains too?
Yeah, yeah, so we have where we have the annual report that's published there. Yeah. Yeah, so it was moved 3 years ago to that other page, and it's hosted there.
Is that where you post like your field day stuff and everything on, or how they get on?
No, it's just a standalone web page.
Okay.
Yeah, that we just created for publishing the variety results.
Okay.
Yeah, then I can send you the link and you can distribute it. Yeah.
Sure.
Yeah, so we publish those by Halloween. So, yeah, and
well, I was gonna just ask, did you notice rust over most of the state this year, or just in parts?
so we noted rust, yes, all over. Was there, I don't know if there was any particular location that we didn't see it. We're usually the first ones. It was drier first in the season, which the year before with the droughts, you know, when we had 2 years of drought, then we had very little crown rust. This year we found a lot, like numbers were really, really high. Maybe it's because of shock, because we're coming out of very little, or maybe it is also because we couldn't score rust for 2 years in a row. That meant that that heavy selection that we usually do early in the nurseries, we couldn't do it. And so then we probably moved lines that had more rust into the trials. That's also probably why we saw so much rust in our trials. Now with the predictions, we're solving that problem so that they wouldn't move even if we cannot see them 1 year, because we're genotyping everything and then we're predicting. So that's a goal, yeah. Yeah. So, but going back to the publication of those results, they are out there, yes, we should review them. They are not, we don't have an increase on those yet. So those are just straight out of this year, what we think are reasonable. I think we need to test them a little bit more broader and maybe do a mini increase this year and then maybe be ready for a decision next year. Yeah. Yeah, great questions. So then just very shortly for the wheat, this is just an update. We have been working on this wheat for food system. So that means that it's hard red winter wheat that is good for baking quality, right? So it's a little bit different than the common wheat or the common winter wheat that is planted in Wisconsin. It's a new market. And it came because there was a lot of need or a lot of people who were interested in this. So this is our breeding scheme, like classic breeding scheme that we did. And then the new things is that we added a lot of baking trials and a lot of on-farm trials into the breeding process. So we did it more participatory. And then the result of that project is that we have this new variety, which is called Big Ford, which is a new hard red winter wheat variety for organic systems and artisanal baking quality. And it has a little bit more diversity into it, and this is, we had a little bit more diversity because we bulked it a little bit sooner in our program before it was all fixed lines. And then we asked the farmers and the bakers whether we should have a very, just one genotype into the mix so that it will be more uniform. And both groups decided that no, they wanted some diversity there. So it does have a little bit of a diversity. That means that plant height, you have a little bit of a diversity. It's been described in the lines. And then for maturity, you have about 2 days of difference in heading. Not too much that it will complicate harvest or anything, but the farmer thought that that was helping the variety to do better in their fields, and the baker thought that that was giving them more stability year to year, because with wheat baking quality, the year is very important in the quality you get, and so this variety was one of the more stable throughout for yield and for baking. So, question, yeah?
There are so many private companies in the breeding programs for wheat. How much correspondence do you pass on to them, or do you pass that to you?
So this one, we're gonna release it with crop improvement. So it's not gonna be licensed to one company. So it's gonna be the same release as the oats.
But I mean, as far as the breeding itself program.
Yeah.
Is there any cooperation between private and your research that you're doing? Is it, are you just on your own?
Okay, yeah, so that's a great question. So I'm part of a consortium of most of the wheat breeders in the US, public wheat breeders in the US, and that's part of the Wheat CAP, a very large consortium. We're about 60 people that are working together to advance wheat breeding to the next level, right? So part of the public community. As far as the companies, we haven't, we've been talking with some of the companies, but I don't have any money coming into the program from the companies directly. So there is no money there yet. And that's part of the reasons why I didn't start with a soft, because the soft market, the soft winter wheat, there is already a breeding program in Illinois that is covering pretty much the area. There is a lot of the companies that are doing well. So starting a program from zero to that commodity market, which is gonna take a lot of money and then many years before I could see any revenue out of that. With this one, I could fund it through different grants program, and then I was able to actually do that with the different grants programs and the wheat cap. And that means that we can have it. And now we have it sustained as that we have the crosses, we're doing genomic prediction, we're doing everything. So we're growing this niche market. They pay a premium, so the seed is sold, even the certified seed is sold at a premium that compared to the oats.
In your program between the wheat and the oat research, how much time do you spend on wheat compared to oats?
So in terms of the breeding, it used to be, 80% of the time on the oats and 20 on the wheat. In terms of the research, it's probably 60% on the wheat and 40% on the oat, just because of the grant money that we get from the different parts. Yeah. Yep.
So what kind of winter hardiness does the hard red have compared to the
Amazing. They don't die. They haven't died on us any year. This one, right? So we did evaluate. We started with a large panel. We had some lines from France. They all died. We had a lot of diversity there. And then we evaluated winter hardiness. And that was the first step here. When we put here adaptation, this means, okay, will it survive or not? So we put a very stringent threshold there. They have winter survival that is more than 90% every single year. This big fir variety has 0 yield penalty any of the years. I mean, we have grown them since 2017 in Wisconsin, And we haven't had one single year where this one didn't do well when it was killed.
And what is yield doing compared to soft red?
Yeah, compared to the soft, the yield is lower. So the soft have higher yield. But the thing is that this one has a premium market. And that means that they get a lot more from the seed than the.
So if you grew a field of this, where would you grow it for? Where would you take it? Most of the co-ops only take soft red.
Yeah, so there is a growing interest on this, specifically for the bakeries and the local millers. So at least in Ridgeway, in the area of, west of here, there is one producer, that has a mill, so Meadowlark. They have been working on this area, and they have been working with that. They are building the capacity in that area. They have the silos, they have the actual mills, and they produce the flour. And then the local bakeries are all desperate for some locally grown hard red wheats. So that's been, yeah.
And they want it in the flour form.
And they want it in the flour form. Yeah, the bakeries. Some of them, like Madison Sourdough, they can actually mill some of their grains. So they could take some, but I don't know the quantities. I mean, they're a big producer, but baker, but I don't know how much they take. Yeah.
Well, if you had soft red that yielded 100 bushel on a year, and you had the hard red planted next to it, would you say that would go 80 bushel? Or?
Yeah, about that. Yeah, that's about what we see. Yeah, but then the winter wheats are higher yielding than the spring also, right?
So is that going to be available then for like certified seed in the future?
Yeah, so we have already, so Albertley Seed is producing some certified seed this year, and there is one producer that is also growing it this year. Interested. Okay, so he didn't do it this year.
Not yet.
Okay, so next year there is another person who's interested, another company who's interested in growing it. But this year, Albertley Seed is producing certified seed. Yep. Yep. Yep.
As far as isolation, and if you're a certified grower, from a soft to a hard, I mean, how do you keep things separate, or how do you? Is there a lot of regrowth? You said it's very winter hardy. I know spraying and stuff, but has that been tested at all, or?
Amanda, do you know what the requirements are for certification of?
For isolation.
Yeah.
600 for corn, I know, but not for small.
So are you talking within a certain seed years, soft versus hard? Or are you talking about carryover?
Carryover, okay.
Volunteer.
I think can you be planted next to each other is what you mean, right?
Yeah.
Can you plant them right next to each other? And one will be hard and one will be soft?
So in terms of
distance,
pollen and things like that, there is very low risk of cross-contamination because they're both selfing. So that's not a big issue in that sense. I don't know the requirements for actually certifying in terms of distance. From 1 year to the next, I haven't heard anything about problems with the volunteers, but I guess you do need a crop rotation for the certified.
You follow the same?
Yeah.
Same type of rotation, make sure.
Same variety.
Same variety, you can grow it, but a different variety wouldn't grow it
I'm thinking of
on
problems
1
that
year.
a person has with rye.
Yeah, okay, so this is, this is not rye.
Rye is a carryover
Rye
issue.
is an insane
Well,
thing.
that's kind of what I'm asking a little bit too here.
Yeah, so rye is outcrossing. That means that you need higher distances because of cross-pollination. But also rye has tons of volunteers, just because shattering is more common than wheat. So rye, It's a problem on any of the other crops, not just on rye, right? So you get rye, then the next year you get oats or wheat, and you still have a problem with rye. So this is not going to be like that. This is going to be more like your oats, where you don't have a lot of
So
problems.
hard red doesn't shatter too much either.
No, we don't have, yeah. Good. So, that's all for this. Then I had, if we still have we're still good on time. Then I did wanted to introduce you to Martin Quincke, who is, let me not double task, so I get it both right. Let me open the slide and then I'm going to introduce Martin. So, Martin Quincke, do you want to come and present? So he is, you're going to have to do it from here. So he is a new scientist in my group, and he comes with tons of breeding experience. He was the lead breeder for a national program in South America before coming, and a national wheat breeding program in South America. So I wanted all of you to know him because he's going to be working in our group to help with the breeding efforts in oats and wheat. And so I think, do you want to?
Yeah. So hello everybody. Thank you for letting me be here. I'm trying to be very brief. I don't want to. Yeah. So as Lucia said, I just joined a few months ago the group here in Wisconsin. My background a little bit, I did my undergrad in Uruguay. I graduated in agriculture in Uruguay back in 1998. That same year I started to work with the National Research Institute and CIMMYT, the International Center for Wheat and Maize, corn, located in CIMMYT. There was a bilateral research program on wheat, and there's where I started my work on wheat. Then when that project finished, I was able to stay at the National Research Institute, working for the wheat breeding project. Later on, between 2005 and 2009, I did my PhD at Oregon State University in Corvallis, working also in wheat and some disease resistance. I went back to Uruguay and joined the group again, and later on I became the principal scientist or lead scientist for the wheat breeding project in Uruguay. Main objectives similar to what Lucia also presented, so developing superior wheat varieties for Uruguay. We were also able to release some of the varieties in our neighbor countries. We were looking a lot into disease resistance, lots of leaf rust and stem rust. More recently, stripe rust was increasingly important. We worked quite a bit on Fusarium head blight and also on bread making quality. Our wheat in Uruguay is also hard red, but it is spring, not winter, and it's for bread making quality. And this year I jumped to the Northern Hemisphere and took the chance to join Lucia's group here at the university and work on all breeding aspects. A little bit on the institute where I worked, called INIA. It's the National Research Institute. La Tanzuela is the location. It was established 110 years ago by Alberto Berger, who was a scientist hired by the government. He was a German scientist, and he established the institute at that time, and he started to work on wheat, barley, oat, and several other crops. And he also worked on industrial hemp at some point. The program is one of the oldest in the Southern Cone in South America. During those 110 years about, we released more than 70 varieties, some of them also present in Argentina and Paraguay. And about the size, just a few numbers, we were doing about 500 crosses a year, some years more, some years a little bit less. we were trying our varieties in 4 locations. Just to give you a rough idea about the size of Uruguay, Uruguay is about the size of Wisconsin, I believe a little bit bigger, but not that much, less populated. So we had 4 locations where we tried our varieties in the main agriculture area, and annually we had about 12,000 plots, breeding plots, yield trials and nurseries and all that. And about the market share, Uruguay grows about, I'd say in the last several years, about 300,000 hectares. That's about 800,000 acres of wheat. But it varies quite a lot. We do a lot of double cropping combined with soybean. Basically, soybean, it's 3 times or 4 times the area of wheat is done also with soybean. So wheat follows after soybean. And Iña had about 15 to 25% or range in market share. So we were covering about that range with our varieties. The rest is all private. And we were talking a little bit of private. This is public breeding. And in the past, Iña was a lot more present with their varieties, but the last probably 20, 25 years, lots of private companies came also into the country and put a lot of effort and funding into breeding, so they were getting some of the market. Just some of the results or research was a very nice study research that we did in collaboration with Lucia's group. Started I think before she came here, so she was still at the university in Uruguay, where we did this genomic selection, and we were able to predict the performance of our lines. We have a lot of genotypic information and also a massive database of field data that we were able to combine, and we did the predictions of lines and also crosses. And then we decided to go into like a challenge or test between picking those best crosses selected based on the predictions and crosses that was just traditional or more a selection, a breeder selection. That was me that selected the 10 other crosses. We did double haploids. We got them back and we tried them out a couple of years in the field. It was amazing to see the diversity. We had a lot of very good performing lines with very good yield. Disease resistance was some bad, some good. So we had a very nice diversity and we studied that. But one very interesting outcome is this variety that's in the pictures that we released last year. It's called Genesis 110. It's a very high yielding variety that came out of this study and this project that we did, and they are harvesting right now in Uruguay. We're finishing harvest, or not finishing. They're in the middle of harvest, and from what I heard, the variety is performing quite good. It is also very good in terms of disease resistance, and it also has a very good quality. And just to finish, since I arrived, I was able to join the team in planting already, the fall planting trials. This was wheat. We're doing the greenhouse trials, crosses, and also this the speed breeding and advance. And I will be supporting the research activities or serial research activities in the group, wheat, oat and barley, primarily supporting the wheat and oat breeding program activities. So I will be trying to collaborate and support all conducting experiments, analyzing research data, publication presentations. I was already involved in the report that Lucia mentioned, and we'll get you the link to that. We'll be involved in field days and other presentations. So with that, thank you very much.
Is printing that link so we can hand it out? Can we do that over lunch maybe?
Yeah,
and
you
then-
can sit and send it.
Okay, so that would be one charge, get that. Secondly, earlier I mentioned for those people close to half of my age, well, at least Maynard's age, we're trying to put you on committees. And certification would be the part that would help with, in our meeting of these variety releases. So you can talk to Sheminder and put your name on the list, okay? So you can participate in it. I have a question. Now I'm just sitting here, not a very good marketing guy, but where did the name Bickford come from?
Yeah. So so this one, we went through a lot of thought into this, and then we ended up with it. So initially we thought it was going to be something with red, you know, where the Badger State and everything is red, and it has a tint that is red. So initially we thought it was going to be red something, or I don't know. But then the thing is that, so we have been working on this as a participatory plant breeding. So that means that farmers have been helpful in the decisions making. And one of those collaborating farmers was at Meadowlark. And
that's Bickford on down 151. That farm, there's a Bickford, right?
Bickford in Meadowlark at
Is it over at you, Jason?
Ridgeway. I don't know the number.
Sounds familiar.
It's Bickford, they had dairy on both sides, they went to grazing.
Yep.
Yep, so it's Bickford.
Yeah.
See, I'm sitting over going, why wouldn't you call it Bakeford?
No, so and he had a farm accident the year before, and he passed, and so we decided after consultation with the committee and everything.
Bickford Farms on both sides of 151. I knew where they were.
Yeah, it's there. That's Bickford, and that's yeah. We've been working, and that's the mill that will take your wheat also at Meadowlark.
Got it.
So yeah, so we decided to honor the collaboration that we
Yeah,
had.
so in collaboration, the certified committee, I know there's some of you guys want to be part of the 4-H side, all that. We can be participating in helping decide on those 3 varieties.
Yeah.
One other overview for all of us, we're all about where we're from. So remember, soft red winter wheat is low protein, cake, crackers, cookies, non-rising. Hard red is you made it into bread. Okay. Historically, wheat, we were the center of the wheat in the 1850s in Wisconsin. Then I went west, you don't need so much rain. So then it was hard red winter wheat in the southern plains, and then hard red spring wheat when you get up to North Dakota where it doesn't make it through the winter. Okay? So we generally are not hard red here. Okay? And that's high protein is for that, and low protein is the soft, which we have, which again, the bakers and the artisan and all that kind of stuff gets into the specific for this variety.
But Jack, did you say they had hard red winter wheat in Wisconsin in the 1800s?
No, well, I don't know what it was in 1800, it was just winter wheat.
Yeah, I think.
And then they planted it, it was mostly over by Sheboygan. They kept planting it, planting it, planting it, and then all of a sudden it wasn't very good. Then we got into rotation, and then a dairy cow showed up.
We used to put a fish next to every one.
But one of the things that it shifted was
a stick, a fish.
Diseases, because of the disease challenge, especially with serum head blight, because of the more rainy summers that we have.
Right.
So that's why it shifted west.
Because you
But
got
we're getting
disease resistance in our high
disease
humidity, and
resistance,
it gets into beer, and why the malt is over there and the breweries are over here.
Yep.
Now you have dark beer, and who cares?
So regarding the disease, I noticed that a lot of the samples that I counted this year had scab. I don't know if that's the same as the
scab, yeah.
Yeah, the scab, and then like when I was doing Dawn tests, like the parts per million was at an average of like 2 point something, so well above the allowed amount.
So what we do is head scab or serum head blight is very important, especially because you cannot sell it for food grade if it is above 1 part per million. And
Right.
so,
Yeah, I
that's something
noticed-
that is.
Yeah, I noticed that a lot, and Mark,
Yeah.
oh, he's not here. Because he redid some,
Yeah.
and
Yeah,
pretty much
this
got
year
the same
was
result.
insane with the moisture that we had at the right time for heading. The level of Fusarium head blight was all over the roof. What was impressive is that in the farmer's field, Big Ford was still below the 1 part per million. So that's why, I mean, we're so excited about this variety. It's because it has all the agronomics, it has all the baking quality, but also the disease. And they are on a hill area, so they do have more wind. So there are a few factors that also, in our trials, we had over that for Big Ford. But in the farm, they were able to get it at that.
So your
Then
research shows like this is definitely like more resilient against like disease.
Yeah, it has more disease resistance than the other ones. And this was selected heavily for Fusarium head blight early on in the process. And then every year that we do have Fusarium, we score, and we did selection for that. So yes, this one has more. It's not going to be a complete, right? Because it's a complex disease. It's very environmentally affected, but it's also many genes involved. So it's not one gene is going to solve. There's not one single gene that is fantastic. The next crosses, we're making them to the one gene that is decent. So we're looking for other sources of disease resistance to further up the disease resistance with Big Ford for the future. But this one is fantastic.
Yeah, so there is no immunity with Fusarium, so
We're never gonna get zero.
There is no variety that is.
Yeah,
But being in the seed lab, you saw the end result, so the
Yeah.
whole life cycle is Fusarium. Fusarium is the same disease as stock rot in corn. So if the grower is planting their wheat on corn ground, and then corn ground being the full plant corn ground versus silage, as opposed to a soybean rotation, the introduction point is at pollination, and if it rains at pollination, it introduces it, and then you end up with some seed that doesn't grow real well in the lab.
Yeah, we never grow wheat after corn because of that. Yes.
But
That's
on
one
the
very
other
important
side,
thing.
the dairy farmer will generally, a lot of times, put wheat on after corn silage, because they can harvest it and get it in. Sometimes if you have a late fall, they don't get it on their soybean ground, is what you really want is a 3-way rotation. So the genetic and environmental effect gets you into where you go, well, that didn't grow well this year. Now, the last 2 years, there wasn't much Fusarium because it was dry during pollination. So now when you inspect some fields next summer, if it's raining a lot, then later on you're gonna see a bunch of samples in the lab.
Yeah, because I saw it in like
End of
rye,
June.
wheat.
Right.
I saw it in like.
And then likewise, because this is an organic variety, that one tool, let's go spray some fungicide, they don't
We
have.
it. Yeah. So that's why we've been more heavy on
Right.
the Fusarium head blight.
But a great question and a good observation from sitting there planting
That's
seeds and
amazing.
watching them come up, so.
Yeah. What are you doing? You're
Yeah.
giving me all this
Who's
stuff.
this grower? You have a special list for us when we send in our Fusarium samples?
And you will see this Fusarium also on other cereals. I mean, on barley and
Yes.
oats.
Yeah.
And,
Right.
Yeah.
Yeah.
Definitely.
When
Good
soft
question.
red, they talk about an LR34 gene. Is
Yeah.
that something that you ever heard of, or is that a?
Yeah, so that's a leaf rust.
Yeah.
Martin have heard about it a lot. A lot of the research was done at his research institute on that
So you
gene.
can, are you
So-
putting that into hard red too? Does that?
So
fit
that's
into-
one that we
That's for
have,
leaf rust.
that's for leaf rust, but that's one that we have been monitoring leaf rust. We don't have as much as in, for example, in Uruguay, leaf rust, but we do get leaf rust every year. And we have also been selecting for that. Specifically, we haven't looked at the markers for LR34, but we should be able to have the cast markers to request
Yeah,
them
I
from the
haven't
lab.
seen the
So we
information,
need,
but
we need
we
to
can-
request that.
Well, they
But
say
yeah.
that if it's got that gene, the tips of the leaves will get a little white,
Uh-huh.
little white edge on them,
Okay.
right on the tip of the leaf.
Yeah, it's what they call the leaf tip necrosis.
Yeah.
Yeah, so it's a phenotypic way of seeing that the plant or that variety has that gene,
Yeah.
and that particular gene is what they call also slow rusting or other plant resistance. So it will give a resistance more in an adult stage or reproductive stage.
Which is
And
what we want in the field.
Yeah, and it will be more broad, not 100% resistant, but it will provide a nice level of resistance that can hold up in the field.
So
Particularly if it's combined also with others, that would be great.
Historical question, 1970s agronomy. About that time is when Shands and Forsberg and those guys, somebody went south, didn't they, to South America and brought some germplasm up here and incorporated that rust into oats? Do you know that history? And was there more of a problem there?
So I think that a lot of research was done in Brazil.
But I also thought it was further south because of the way opposite of us, as opposed to Brazil's kind of.
Well, it's south of Brazil, so it's almost Uruguay.
Right. Okay.
Claim
So
it there.
I
It's Rio Grande
remember
do
on some
Sul.
class, if
So-
I ever went to a 7:45 in the morning because I wasn't studying
Uh-huh.
on Thursday night on State Street, I remembered them telling that germplasm came from South America. Is that how that went? For those of us who went to school here?
Yeah. And we're still part of a nursery that's,
Right.
it used to be the Quaker nursery
Okay.
that allowed those type of collaborations, and now it's called just the International Oat Nursery, and it's being run by USDA instead of Quaker Oats that was purchased by PepsiCo, and PepsiCo kept running it for some time, but now they're no longer
Yeah,
running
because those old varieties were like
yeah.
Dahl and Froker.
Yeah, and they were more forage varieties, but they have done a lot of great research on.
But that, some of that
yeah.
breeding work came from those varieties
Yep.
from
Yeah,
down
from
under,
Brazil.
or
yeah,
on
and the
other
breeder
side?
is still active. It's retiring soon, but he's a fantastic breeder. Yeah.
Got it. See, I did go to class once. Okay, any other
Good.
questions?
Are you starting a software program, or is that just a lot to take on?
For now, it's a lot to take on. If I can figure out a way of funding it, because it's gonna take at least 10 years to get it, start producing any variety and 10 with luck. So it's a big investment for a very delayed return. So right now, I don't have a lot of manpower to start the soft, but we'll see. I mean, the idea of bringing Martin is to help with all the breeding, and he loves oats, but he loves wheat more, I think. So the idea is to increase the wheat, and we'll see. For now, I like to only get on things I can handle. So we started with the oat was managed. We started with the hard red wheats because we had the funding from the grants. So we started with that. So we'll see. If we can figure out a good source of funding for it, we'll be happy to take on it. But for now, yeah, it's not gonna happen in the next few
So
years.
another overview, this gets in the historical part. If you understand how wheat breeding went, okay, when we go to GMOs, we start out with soybeans, and then there was corn, and some big companies were on some of their sacred ground, then went out and bought up all the small little breeding companies. Monsanto was one. They had a company called Westbred, and Westbred now has turned down their breeding program, and so did a couple other companies, Syngenta. And they all ran after hybrid wheat. And they're going hard red hybrid wheat out in the plain states. My word is, in the last 2 years, it's not going well. Nope, right? And part of it is it was to capture the value. In hybrid wheat, you had to go back and buy seed all the time.
Yeah.
Now, those of us who are older, anybody know the company Roman Haas? Okay, Roman Haas had hybrid wheat 30 years ago. Well, they can either do it chemically or some other way to cross it. The seed comes out really shriveled, but it's very expensive. So then they said, well, just plant less of it because it's costly. Well, you and I all know you got to increase the population, get more yield. So that all went away. But now throw in 30 more years of historical, I don't have a memory, they're back in the hybrid wheat again. But now they're going out to where they're more cost sensitive in the plain states than we are back here. But they got way more money than all of us to be that smart. So they bought up those little companies, they're all gone. There were a lot of one people breeders, and they thought that that was the next place to put GMOs. But how many people sit there and eat a sandwich and say, I really like that genetically modified, and that's what they were gonna do. Is that a summary pretty good, Jason? Yep, and he was the president of a section of that, right? Yeah, okay, so, you know, pardon my brevity of how we get to where we got.
Yeah.
So, but anyway, so there's some opportunity here, I think, on the public side, for the
Yeah.
public good.
Yeah.
And that's kind of where we're all here.
And we're part of the Weed Cap, so that means we have great collaborations with all the public, and that means we also change germplasm, and we have been part of the nursery, so we're testing some of those. So we're building slowly the machinery in case we want to go there if we get more funding.
So all of you who got deep connections to some of the people with lots of money that lean left, you can maybe get some funding for grants that can go to the public side.
That would be fantastic. Or even check off money. I mean, all the other states have check off money
So,
that goes to.
I did my politics again, sorry.
Yeah.
But if we can get those printed, it'd be good. And then, I think, any other questions? You're here for lunch, right?
Yep, we're here
Right?
for lunch.
Then we're gonna now finish up with the guy who's so big on words, we're probably almost gonna miss lunch over Greg speaking, right? Now, the real question is that how many minutes will he make it last?
I can shave a lot off because.
It looks like you've shaved more than.
Yeah.
Thank you for
I'm full of
that
BS,
play.
but I don't have to be. Okay, I did want to say one thing. I heard you guys touch on hemp, ditchweed, before I walked in, and my son is 6th generation on our farm. And back in the 20s, 30s, whatever, it was a hemp farm. So we've got a lot of hemp grown in our ditches and our field edges all around the farm. And I'm sitting in my living room one morning drinking coffee, and I see this. I'm in very rural area, and you notice things. I see this black, like 76 New Yorker. You know, they're boats. I see it go down the road. Yeah, haven't seen that car before. 5 minutes later, I see it go past again. And then 5 more minutes go by, and I see it pull up to one of my field roads. And this guy jumps out of the car, and the car takes off. And I'm watching him run down the lane, and what the hell? And the car come back, and it stopped at the end of the lane, and this guy come running back with 2 big black trash bags full of ditchweed. He jumped in the car, and they tore off like they got away with something, you know? I'd have loved to see the headache they had. Wow. Anyway, for those of you who don't know me, my name is Greg Helmbrecht. I run the seed compliance program for the Wisconsin Department of Ag and Ag Resource Management in the Plant Industry Bureau. And I am going to be quick. So I started working or managing the program in about 2000. So we're 25 years into this now, and this is just a kind of a picture of our compliance sampling compared to the area states and where we sit. For how many samples we take and how many violations we have. Now if you look, we got 1,100 samples, 1,500 samples, 2,500 samples. Those guys are all focusing, they're sampling gangbusters on corn and soybeans. Okay, when I came into the program, I had to identify, because we have a limited amount of money to sample and test. Corn and soybeans, if I sampled that much corn and soybeans, I'd have a 1-2% violation rate. There's not issues with corn and soybeans. So I turned the focus back onto where our problems were. That's why we have fewer samples than them. Case in point, this is every 5 years since I've been running the program. we had a 20.69% violation rate when I started. That means that 20% of all the seed I was out there sampling was in violation on the label. So I wanted to focus in on where our problems were to drill down on it, because all the corn and soybeans in the world, I wanted that rate to come down. So we focus on problem seed, labelers that have consistent problems annually, and then randomness, we also incorporate. I still have to sample everything. Problem seed, problem labelers, and I'll remember. Anyway, little by little we even got down to 4% in 2022. And this past year we were at 6.6%, which is about where it should be compared to other states. Okay, the other thing is I want to sample every seed labeler. Our goal is to sample them at least every 3 years. And it's a little difficult because a lot more stuff is sold online nowadays, so we don't even get to see it. And then seed labelers with a violation trend exceeding the current state average, and then kinds of mixtures with a violation trend above. That's where the focus has been, and I attribute that to lowering since we focused on it so long, that violation rate went down each year. New this year, licensing online. Some of you may have got your seed labeler's license renewal notices, and you saw you could do it online. First couple of years, it's going to be a headache, but some of you got through it, and some of you sent in did it the old-fashioned way. But that was a big thing to get all that data into this new system and start licensing that way. So hopefully we get through it. A few years from now, everything will be status norm. So that's just a little data on that. Is this available to my presentation so they can see the links and the?
Sure.
Okay.
Yes, we
Great.
can email it.
Great. Okay, this is the thing I really want to hit on, because my goal overall is to lower that violation rate, okay? I'm part of the Association of American Seed Control Officials. It's a group of people from every state, my counterparts, and then USDA in Canada. And we meet annually to discuss new issues, problems that we're seeing, and we have a document called Russell, Recommended Uniform State Seed Law. We drafted, or we made that document to recommend if a state has to change a seed law, that they follow that Russell. The reason for Russell is to make seed laws as uniform as we possibly can from state to state, to make labeling easier for you folks to be able to move your seed across state lines. So obviously there's different noxious weed seeds in other states, so we can't address that directly in Russell specifically. But the labeling requirements we're trying to get it so that everybody's doing it the same way. And then we also have a document which I'm going to hit on next here. We have a handbook on seed sampling. So it's really, really important that the sample you're submitting to the lab be a representative sample of the lot that you're testing, okay? When we take samples on the compliance end, we follow this guideline. If we're doing it this way and you're doing it this way, we should be getting the same results, basically. We even use your same lab. So Scheminder's going to be getting your samples. If you're doing it following this guideline, you're doing it the exact same way we are to collect a representative sample. If we're all doing it the same way, we should see violation rates drop. Now, if you're just going in and hand scooping some seed and sending it into Schminder, our results aren't going to be the same. It's not going to be a uniform sample of the entire lot. okay? That's the goal. If we're all doing it that way, we'll see that violation rate drop even more. So, you can order that handbook through me, because I'm the treasurer for the association, and I take care of all the handbooks. So, my contact information, Shaminder can share with you, or you can write it down when we get to that page, but that's, I would really like to see everybody in crop improvement using that document. It's also used federally and in other countries.
Is that a small handbook? Could you just send one to every seed labeler, that everybody that has a seed labeler's license?
If they order it. See, it's a published document produced by the association, and we get $40 a piece for them, so that we can keep producing them. It's what they said is the fee. Unless you ordered more than 10, then it's $35 a piece.
$40.
Yeah. And there's also an online test you could give your staff or people that are out there, so they can check their competency of being able to, it's an open book test. Can they find what they need? It's not that difficult though. So, yeah, basically this is just an advertisement I did for. Yeah, that's it in a nutshell. I did it in 7 minutes. So yeah, if you ever have questions or problems, Shaminder will have my information out there, and if you have questions for me now, shout them out, because we have time.
Those violations, what is the biggest culprit?
Germination this past year, wouldn't you agree?
Mm-hmm.
Yeah, and I blame a lot of that on how people store seed, because our germination problems usually come from people, not so much on your end as much as the people that are selling your seed. They're not storing it properly.
Oh, you mean it's not good to have a 2-year sample, label on it that was on our name, and then you send me a nasty letter saying that you're.
Oh, has it ever been nasty?
Bullshit, that's the only way you guys know how to communicate.
I know how much you love government, but I've been nothing but fair with you, Rick. For 25 years, I've been nothing but fair with you.
I'm just telling you how it is.
I know. Do you see a DNR here?
I lit up the guy from the
I know
scales,
who you
too.
don't like.
I lit up the guys from the scales too. They go
Okay.
to work, they were supposed to inspect it, right? And so the state comes out and inspects it, and we had already inspected and sent it in, but I got a nasty letter from the
Okay,
state saying,
all
if
right.
you don't do that, you're gonna
No.
be fined, and that
Then
just
you're, again,
me.
you're talking about the DNR, and you're
No,
talking about
that's-
weights and measures.
That's
This is who I
Department
am
of
now.
Trade and Consumer Protection.
Yeah, okay. My goal, and Ag Resource Management's goal, my entire life, or 25, 30 years now with the state, is education through compliance. I will tell you first what the problem is. If the problem comes up again, I'll tell you again in a little stricter fashion. I don't go out and issue fine. Have you ever been fined by me?
No.
I didn't. All right. All right.
I didn't hear that no very loud.
See, I always expect him, because he hates government.
All the rest of us expect him to.
Yeah. Education through compliance. It's called voluntary
Well,
compliance.
what I-
If
all I
I
wanna-
hold your hand a little bit and guide someone in the
All I
right
wanna say
direction,
is the tag was illegal to begin with because it was older than a year.
then it shouldn't have been sold or offered for sale.
Well, I wasn't selling it.
Well,
I didn't even know it was
whose name was
around.
on the label?
Ours.
Okay. So do I issue the fine to or the violation to the person selling it?
Well,
Or do I notify
how
you?
How do I know that there's something out there that's over a year old? It's
That
impossible.
it is impossible, but it's a hard thing to police on my end too. How do I know you didn't send him that seed? Because I hear that a lot is, Jesus, they just sent me that seed last week. It's already expired. You need to pay attention, you need to communicate, and you can always call the seed labeler and discuss it. Maybe he has new tests, maybe he has new tags, maybe he'll take the seed back. But I've never fined you.
They feed-
I've never
they
brought
feed-
you in
they
for
feed it to the
compliance
horses.
issue ever. Not to say that you have never been wrong, but. So
Never
be
been.
nice to me. I've been nice to you.
What do you do with some of these guys that wanna put, you know, their own name or whatever, and they want like an 80 germ, and you know the stuff's 98?
They want it?
Yep.
That's up to them then.
But then what now, now are you still in compliance with a 90 germ and come back with a 98? With a real germ, a 98, are you still good at that?
Oh, yeah.
It's better.
You're
Yeah.
good.
Yeah.
So then, okay, cause then you're down, then you can slide down to 75 actually too with that 80.
And you wouldn't get a letter.
Sure, but then you're screwing yourself on
Well, I know, I'm just trying to
competition.
see,
It's
just trying to see, cause it's.
People always give themselves a little wiggle room. I always advise that. Don't overclaim or don't say, if
But
you
you
came
can't-
back
you
at
can't be too
99,
few.
don't
At
say
least if you're better,
99,
you're
say
good.
98. You're not screwing yourself out of anything then. The problems that I've had and I've learned over the years is if you have a mixture, sampling a mixture, it's pretty hard for me to do anything on purity unless it's way out of whack, you know? Unless I go and sieve the bag, sieve an entire bag. It's hard for me to do violations.
But Sheminda doesn't have much time to count every seed in a bag. Because she's probably the expert in the state of identifying.
Yeah, well, and there's been more and more challenges over the years. Refuge in a bag was a challenge for labeling. All the seed coatings, everything's coated now.
Yeah.
That's been a challenge, especially on your end, I imagine. There's always things pop up, but,
Oh, it's refuge in the bank. They don't have it labeled as heavy enough or what?
no, refuge in a bag was a challenge because you had two different seeds.
Yeah, but
And anything over 5% needs to be on the label, okay? So you've got, they're pretty much the same variety, they're supposed to act the same way
They find
anyway.
the cheapest shit they can find in the box and put it in.
And industry went along with it. Our suggestion was, okay, well, how are we going to identify, how is the lab going to identify the different corn in that bag?
Color.
So we suggested color. Can you color the refuge portion different than the other portion? Then I had people saying, well, then the farmer's gonna sit and pull this seed out. I'm like, have you ever been a farmer? And can you imagine sitting over a grain drill, pulling the green seed out?
So, did you have a farmer on that committee that was talking about
Oh
it?
my, no, it's just suggestions. Like, no one's gonna do that. Who's got that kind of time?
Mr. Sayers does.
Yeah.
What do you do when the inspector comes out and when we're bagging, we put like a half a pound or a quarter of a pound more in the bag? So just on the scales. The inspector comes out and gonna red tag you because you got too much weight in the bag. It doesn't say 50 pounds and we're at, the bag weighs, say 50 pounds and we're at 50 and a half or something.
Did you have someone do that?
You know?
Not from my staff. Must have been
No.
weights and measures.
We had to open up 300 bags and take it.
Really?
Are you kidding me?
No.
You just had to put a half pound free on the bottom of the label.
Yeah.
They were mislabeled on weight.
That's crazy. Yeah,
Had to
because
have
I
the exact weight.
I would never instruct my staff to
I
do
thought
that.
there was like
But-
a slack room of a 0.5% of a pound or.
Well, not to mention
weighted
you
bag
sell
or
things
something.
by seed count sometimes now too. So how are you supposed to do that? And
You said you belong to the States and Canada.
The association does, yeah.
Yeah. How does Wisconsin compare, you know, with the standards, the general standards compared to the other states or Canada itself? Maybe that's a pretty broad question, but.
Canada and USDA, Ag Marketing Service, pretty much have the same standards, and at a state level, we follow whatever they say. So we compare very, very closely. Obviously, Canada is canola. I mean, that's their big thing. So, I mean, we all have, because of the regions we live in, we all have a little bit different stuff to focus on for crops, but very close everywhere for standards. And they're developing new standards all the time, which is a challenge too, especially for the lab probably. For the native seeds, I don't know how many they've come up with new testing procedures for natives. Is there still stuff coming out left and right or not?
There is, yep.
Call me anytime with questions.
I just had another comment. I like you to test as many samples as Missouri does.
Okay.
And you remember how big that number was?
Yeah.
And then, so you guys all know, they pay us to do the germination tests, and we have some budget things if you forgot that part when you weren't here. So if you could increase your numbers, was it 3,000? What was that number?
It was a lot.
It was a lot. We think that would help our budget.
Yeah, it probably would. You know, I wouldn't mind taking more samples, but there's only 8 of us, and each one of us is a nursery inspector, seed inspections, field inspections, crop inspections. I didn't mention, I also run the phytosanitary program for the state. So that's the export of all plants and plant products, from azaleas to ash lumber. If it's a plant or plant product, you have to have a phytosanitary certificate that meets the requirements of the country you're shipping to. And we do roughly 12,000 of those a year, which equals, not for everything, because we do statewide surveys that cover a lot of things, but we have to inspect all those shipments going out. So we're stretched pretty thin. I'd love to sample more, but I'd probably get my head cut off by my staff. It'd be like, no, we can't do, they hate seed sampling. It's my favorite thing to do, especially at Kratz's.
Okay, more questions? And he'll be here for lunch.
I did 3 phytos for you today.
I know.
All right.
Okay, well, thank you very much.
Thank you.
We're keeping you busy. Samir, you want to give us our next guidance?
Yeah.
Lunch, and we're serving, is it a make your own sandwich thing?
Yeah. Thank you. Let me just
I think it's all sitting over there.
Yeah, it's all
Yep. So we'll break. We're back here at 1, I think. Is that what it says? Very good. Thank you, guys.
Thank you.
And Mark, were you able to print off those results?
Go do that right now.
Cool.
You want the full publication?
How big is it?
It might be some pages.
Obviously a forage and forage and
Yeah, I'll get those in 4 pages and print out.
Or maybe you want to print one, bring it out, Shawn and I can look at it and go through it all. Or maybe the first person through could print after, let them, however, I think this group would like that.
Okay.
Thank you. Grab a sandwich when you go by. Okay.
Yeah.
Here's a magic touch. Yeah, no, it's like anything that kid go. Yeah, how you prove a fight before you
I know.
Yeah.
Yeah, they're always got different size bags, different weights of bags, you got different ones pop in them, different overhangs, and things like that, so. I think they have 5 or 6 programs in there that cover most of it, but there's some fine tuning.
See, that's the stuff I like.
Hey, man, how are you doing, my guy?
Good, how are you?
But they're actually working on something.
Well, I got limited doctor's work.
I don't know what that before.
And that grew from back. Like, am I that old? Like, I can't see it. Because it was that orange one with the red box underneath, right?
Yeah,
Is it concentrate?
Anything I try to do, I say wait, maybe tomorrow.
And he's, you know, he's gracious enough to,
No, I get it.
planning group and stuff like that. So he probably, he's probably thinking more of that than he is. No. Big
So you can't get your hands on any work?
Yeah, I know.
I just asked my
Doesn't
guy.
sound right to me, but.
And they have 500,000 pounds.
Yeah.
Who's your guy?
Like you said, winter's coming.
Maybe I shouldn't tell you these things.
The old
Yeah, because Tim Powers, the guy I overview some Deer Creek. Yeah, when you were telling me about that, I said, like, I'm sure you got some of this, and it's like 500 pounds. I want some.
I was looking for some. Yeah, tell me, I'm
Here's the deal.
Yeah, sure.
I always call it Elliot.
You know, we get big money to keep us afloat.
I could send you that Tim's
Income. Just to forgive this.
But you don't know, I also.
I think so, but I think it's more.
I know there's,
You know,
How young is he?
he was a man that you felt, you know, he was old.
Those are two options.
You felt so restless. Coming forthright with bringing money.
If it's dry,
You know, and stuff like that.
like a lot of the fruit stuff.
And I just like, so where'd you get your grind? He's like, they still have it.
So we own.
I didn't believe her, but yeah, I said.
That's your sitting to your left. Okay.
Even private.
Would I? Cross. Oh, that's weird. Do I think I should be?
Where do I start watching?
It doesn't feel good.
Yeah.
It was weird coming in here. Did you park in the back?
Oh.
Or are you in the front?
Yeah,
Yeah, in the back.
we made it. It wasn't come all right.
Maynard, I haven't seen you in a
Oh, I
long
gotta
time,
shake her hand,
Roger.
sure.
A long time.
Deer hunter too.
Oh, is that right? You must, that's how you, he doesn't get on the crotch
Yeah,
line.
I think that's when we're redoing the seagull.
Yeah, we were discussing quack and all this serious stuff, you know.
Have you been invited on the Kratz farm for hunting or anything
No,
like that?
no.
Well,
See, yeah, it's all good. Maynard hasn't invited me up either though.
Hey, we don't call it a hunt, we call it a harvest. Too damn many deer out there, it's hard to get the first 2 days, they hide.
oh, you
What
bet.
do we do?
We shot 18 on our farm.
This year?
Nice. 2 years ago, we shot 25.
They know how to hide it underneath that.
We processed 15 deer on Saturday.
Wow.
Got them all done. It started at. My farm's at one. Oh, yeah.
question?
Go in?
And how much was the last one? Hey, is there some of those bends still on the auction today? Okay, so here's a heads up. Yeah, no, not a problem. I didn't know the information. It'll happen again, trust me. Yeah, I already told him. Have you ever, when's the last time you've been by his place? He's got a bunch of beds. Right, that's my point. Yes. Got it. How tall is it? How long is it? Oh, yeah. You gotta start turning in Columbia County to get Dodge County. Right? Oh, you don't have to. Just make sure you don't go in it and stuff. Yeah. Where are the guys working at besides you? Yep. And is Ryan driving truck again? Sounds good. If you see Rory, tell him, well, I'll give him a call. Maybe I'll leave him a message. I got a little break now. Doing lunch. And the line's long. Okay, did you see Danielle by chance? Okay. Sounds good. Well, first, figure out what we got. But we need a kind of plan, just together as a team. To talk about. Okay. Get out of your way. Bye.
2023, this must be the most recent, right?
No, it should be 24 data.
I don't see that.
So one.
That's just winter wheat.
Yeah, so ask her where to find it. She's city printer. Quick question, we have the data that we were trying to get done from Lucia. How many would like a copy of it today? Okay. Mark's gonna count. I'll take a copy. I knew that this group of people would have wanted copies for it, not sent, obviously correctly, but he's now got nothing.
Yes, I did. All right. Thank you. I couldn't get out of it. They were
Okay, yeah, there's a bunch on the market. We actually sell some ourselves that we recommend. It's more of like a commercial grade product. We have a lot of luck with it. We actually did feeling systems working with it. So we're big fans of it, the stuff that we have. Not saying that anything else is bad, but I just witnessed, you know, the stuff that we have that we sell that works really good. So, and then we have, what's that? It's just an enzyme that we get from the supplier for it. It just eats the biomat away from the drain field. So over time, you get a biomat, you know, in your drain field, and it just doesn't allow fluid to, you know, drain. You know, it kind of plugs up, which causes, you know, issues. It backs up in your tank, it backs up in your house. Well, nowadays you pump your tanks often enough. I always recommend just putting it into your drain field if you can. As in, like, your outlet end of your tank. If you can get at your outlet end of the tank, sometimes you can. If you can't, then I just add it into the tank itself. But it's more beneficial to get it into the drain field because you pump your tanks often enough nowadays because you're required to get it regularly pumped every 3 years. So it's yes, right. Yeah, the less, basically, if you add it in a tank, it's fine, but you're kind of just diluting it more. And, you know, eventually it's going to get its way out there, but like I said, you don't want to spend money on it and then get it pumped out, which I always recommend if you have like a single tank, pumping it more often than every 3 years, depending on the number of people that are living on it, because you want to limit the solids getting into your drain field. You know, that's what makes it fail in the long run. So if you limit that and you know introduce bacteria in the drain field, it will eat away at that biomass. So okay. Okay. Oh wow. Yeah, you should. Yeah, I would recommend pumping that more. I'd do that yearly for sure. Okay. Yeah, that's small. Yeah. Yep, you might have toilet paper and stuff floating on the top. You just don't have a lot of capacity for that. And that's when you don't have capacity, you don't have, you know, your septic tank it's supposed to settle out. You know, the solids go to the bottom. You're supposed to have kind of like a clear water in the middle. If you don't have a lot of space for that to get, you know, clear effluent out to your drain field. Eventually, you make the solids. It's like every time you use water and you walk in like a sandy beach, you know how the sand particles get suspended? It's kind of the same way. When you run water and you agitate your tanks up there, you're gonna push those solids out to your drain field. Yeah, that's not good either. Yeah, I would definitely pump that out. It'll save you money in the long run. You know, so. And we can, when we pump it too, if you make a note, you know, in your schedule, to add some bacteria, we can add it. We have stuff that we can add right there, a one-time deal, but it's better, we have different product. It's the same product, but it's in individual packets where you add it monthly. If you can't get at your drain field, then you're better off just doing a one-time thing. But sometimes we recommend to do that and the other way, where you can add it monthly, because sometimes, you know, people flush stuff down the toilet where they're not supposed to kill the bacteria. This way it'll reintroduce bacteria. Well, it's regardless what it is, it's a year supply. It's $75 for a year supply. You can either do a 12-month or you can do just a one-time, like basically jug where you dump the whole stuff in there right away, which is probably what I would just recommend, since you don't have decent access to get 2-year outlet. You know, you just have the pump tank is where I would add it after you get it pumped. Because yeah, then eventually you get it out there. Because you have a smaller tank, so even it wouldn't even be bad to put it in your tank, because you know it's not as diluted. Most tanks are like 1,000 gallons, you know, so it might work its way out there more than normal. But I would suggest adding it for sure. I would probably do both. I would probably do the main stuff, and then I would do the monthly stuff. There's a packet. You can dump it in one of your sinks. It actually, it's like a Drano too, so it actually clears out your heat traps and stuff in your house. So it works kind of both ways. They're the same price, so it'd be $75 a piece. It's the same amount of product. So when you add all the packets together, that's how much it is in the jar. Yep. So then you're at 150, correct? Yes. And then so we give you the packets, and then don't just buy the bacteria. Get it pumped out first. Do a clean slate, and then add that bacteria in there. If you're planning on doing it soon, you don't want to waste that unless you can get it out to your drain field right away. I would recommend dumping it in your pump chamber tank. But first clean it all out, get the solids out of there, and then introduce it. Okay. Okay. Yep. Yeah, I don't think it's going to hurt anything. There's a lot of products, and I can't distinguish them apart. There's people that, or companies that, just kind of add filler stuff, more like a sawdust, with whatever bacteria. So, but the only thing I can say is the stuff we use, and we've been using it for years. I've seen weak systems that are taking water, and we slowly kind of nurse them and yearly. Introduces bacteria and work it. Customers are just very happy with it, because it beats spending $25,000 on a new system. Yeah, and then you have to rip your deck apart. That's the last thing you want to do. Yes. Right. So. Yep, just make note to the office. I mean, you might not be talking to me, you'll be talking to maybe a dispatcher or something, but, yeah, just mention that you want the bacteria in a jar, and then you want the 12-month supply of the individual packets. So, all right. Well, yeah, no problem. Hey Jeff, this is Jason with 5-Star Inspections. I missed your call a little bit ago. I'm alright. I'm in a meeting today, so that's kind of why it took a while to get back to you. So we're just on our lunch break right now, yeah. So what can I do for you? Okay. Yep, okay. Yep, I recall, yep. It's more of a bad sign if before testing. So like if I wasn't testing, before testing that Untitled was dry, and then after testing there was some ponding. But the ponding slowly seeped away. So meaning that the effluent was getting to the end of the drain field, but it was eventually absorbed. If that makes sense. So. Yeah, that's a $1 million question.
Wisconsin Funding Seeds. Just going to give a little update. 24 seed sales, sold a total of 4,900 units. That's compared to like 4,200 units, so pretty similar to previous years. Let's see here. Foundation seed sales, total units sold 360, then Harpoon, Kaskaskia, and Spooner Rye. Got a good supply for spring of 25. Most of you guys are growing those, so you know what they are. Anago Badger, Esker, Forge Plus, Kiwani, George Mink, and some conventional soybeans. We already talked about the new Bickford variety. I got that Meadowlark is growing the foundation for us. Should be a supply of that available in the fall of 25. We didn't do any variety increases this past spring. We grew George oats, and then this coming year we're going to plant some mink. That's about all I got. We did a little electrical upgrades in the building. Otherwise,
What's your inventory on what you got available?
I don't know exact inventory, just good supply, so more than what we have sold, I would say. I don't know if we got more questions about what we're up to, or?
Hey, tell Mark the dessert was excellent.
Yeah, it was good stuff, yes.
Maybe this is another dumb question from the back corner. I wasn't here at the beginning. What's this make?
Oats?
Yeah.
It's a new variety. It was,
And it's in that data set. Did you get a
Yeah.
copy of that?
I did.
Okay, it should be
But
in
this
there.
is a new one.
And
not that new, 2 or 3 years ago.
Yeah.
the naming of varieties is always interesting. Sometimes it's towns, sometimes it's last names of people that are before, sometimes it has something to do with what it does, like Forage Plus. Mink has something to do with, there is a lot of mink in this state raised commercially, but it isn't very receptive mink to people living in Dane County, because you don't, or Aspen, Colorado. They're not too big into mink stoles like they used to be. But it works really well, mink, because you take down and out cows and you feed it the mink. Does that help you in the life cycle? For those of us know that, right? But it's a couple, I don't know, it's in the chart, it's that every couple of years a grain variety. Anybody else got a description of it? It being
Very early, very short.
Right.
Yeah. It's Shumage kind of wanted that for milling.
Okay.
Yeah.
For
It's very short and it's very early.
and for dehulling.
Yep.
Well, so that works for Randy, because when did you get done harvesting seed oats this year? What day and what month?
I don't know.
What month was it?
Oh, September.
When?
September.
September? Yeah.
Right on schedule. Right on schedule.
So Randy is probably the latest guy to harvest anything just before you put Christmas tree lights on.
He does that so he doesn't do field inspection, because all dirt at that time.
Mark, what's the price of foundation seed this year?
What's that?
Price.
The price of
And I wouldn't know. I'm more of operations, Mark's more of numbers, so I guess.
I don't know when we get that information.
Another month.
Another month?
Yeah.
Right.
So how come you guys, Lucia was saying about the increases, they're worried about too much extra seed, or?
Yeah.
Of the 3 varieties?
Yeah, because I mean, to be honest, you guys shouldn't really worry about that. If they need to increase, we should just increase, and we can always find a home.
Right.
Yeah, because there's 3 forage varieties. Well, you were here when she presented.
Yeah, no, that was the first I heard of it too.
Yeah.
What I would suggest, because I'm talking about the old days, I used to help Foundation Seed. If they got extra stuff, we would buy it off of them, at a downgraded price, and sell it into the retail market to move it to keep you guys inventory and make you willing to do that again for you. But you can't, I'll tell you this, you can't sell from an empty shelf.
Right.
If you don't have supply, you can't sell it. And so there's a lot of oats being brought in from all over because there's not enough supply in this state. And so
I wonder
if
if
you've
the
got new
market's
growers
not-
that wanna come in, you can't even give it to them if you don't have enough seed.
Have you seen us trying to buy oats from us and us not having it, or?
No, that ain't what I meant.
Well, that sounds
Somebody
like-
that goes to work and wants to grow, because there's not a lot of people gonna grow corn for $4.
I'm just seeing that, are we seeing the demand for more? Cause I know we've had oats sitting around just dumping them, you know.
All what you gotta do is get more people to join the crop improvement, so that you can get them into that market. They gotta find an alternative to corn, and I think at the current market rates, they could do better than what they can with corn.
What do you dump on this year?
Well, just go to, you know, the elevator or whatever, just cause they're sitting around. Yes.
Because if they're cleaned up,
We could move them.
you know, as cover crop oats or something, you know.
Okay.
I know, we gotta make sure we follow the laws on those stuff too, but I mean, if she wants an increase and you're like, we don't want an increase, we don't know what to do with the seed if we don't go forward.
Right.
We shouldn't really worry about that, it's better to have the seed.
And the old model, before you were there, or before the current foundation seeds, all the foundation went through you guys.
Yeah.
And now we have a core group of us that are doing it, so that supply should be pretty good there.
That's why we're bringing
In
this up
case-
to you guys, because I don't think you have a historical idea of how all that stuff works. Because technically, you're supposed to have, I think it's a year's worth of supply on hand in case there's catastrophe that the
Right.
seed is no good.
I guess my only thing to that would be is I don't think we see the demand for it. I guess if the demand was there, we'd grow it, but.
Well,
I don't.
and the other couple, as we all know, I have this thing about how do you start a war. $11 wheat happened all of a sudden because somebody marched into Ukraine, right? Had nothing to do with not having enough. Market went to $11, and now it's crashed to the other level. That was nothing to do with supply, demand, or climate, other than people marching and shooting at each other. So now it's crashing down. There's all kinds of grain going on. We only would know how soybeans are going to be exported to China based on some new things happening in 5 weeks. And then the other factor you always have is, do we have winter kill and you need to plant alfalfa? And none of that can be done on a spreadsheet.
No.
Who's going to start a war? Who's going to start a drought? Who's going to have winter kill?
You'd never know.
No, so
You never know.
The
But
job
if you
is-
don't have something in the thing, you can't very
Right.
well sell it no matter what.
That makes sense, yeah.
So I
It's nothing to do with
I would
variables.
do whatever we could to help you to get to that. And were you down by us?
Yeah, one
Yeah.
second, I think.
Yeah. So that's what I'm trying to bring to your attention. I mean, a couple of years ago, we were dying with Forage Plus. We had so much forage. All of a sudden, China came along and bought a shitload of containers and it was gone. So, but we couldn't have done that. We wouldn't have had the inventory is what I'm trying to tell you.
Right.
There should have been a little spike based on the last election with a 10% tariff.
I ain't worried about the tariff.
I was referring to the China and who's charging who.
Yeah, well.
Did you?
Did
That's
you ever,
just my
did you ever
political
notice, you know, you just talk about this for a second, with these tariffs. Because what's the first thing that happened is he threatened it, and then the leader of Canada came down to talk to him, and the leader of Mexico came up to talk to him. They are never gonna happen.
Right.
It's a threat. It's
So
a
was,
bargaining tool.
so I digress. So was the threat when it was said, well, Canada could become the 51st state. Did you hear that yesterday too?
That was funny.
Yeah, I know. Hey, we gotta be entertained.
Well, yeah.
Right? So anyway, we digress.
Yeah.
Not supposed to talk about that stuff. But information you can take back to Mark.
Yep.
And we'll have, when we have our certified meeting, one of you guys will be there. We're gonna be a little more active. And then I'm reminding those of you to let Schminder know what committees you wanna be on. And we'll all be in that participative share of information. Good, thank you.
Sound good?
I think we took you over your 7 minutes.
Oh.
Okay, there we go. So our next speaker It spoke to us before, biological nitrogen fixation by aerial roots of maize for sustainable agriculture, of which Mark was trying to talk about this earlier. And Shawn, Michel, Anne, who knows if I pronounce French right?
You're perfect.
I was in France one time this summer at a destination wedding for a nephew who got married in France. So I was over at Provence. So here we go. And you know if this is all turned on, you think?
Yeah, it is.
It is? Good, thank you. Oh yeah, the guy controlling it is back in the corner. Hi.
All right. Thank you for giving me the opportunity to talk about our work on nitrogen and nitrogen fixation for cereals. So for my background, I'm a microbiologist. I worked with microbes initially on legumes, working on nitrogen fixation in legumes, mostly soybeans and alfalfa. And about 10 years ago, I was a bit frustrated that, well, in practice, improving nitrogen fixation in soybean is very difficult. Like nature is great already, breeders have done a great job, and so I was thinking, you know, where I think I can have really an impact with my kind of research is really on cereals, because there it's so poor that for sure we can have an impact there. And so that's how it started. So as a quick reminder, I just want to remind you, as you probably know all, that our crops most of the crops get nitrogen from the soil, mostly in the form of nitrate and ammonium. And what we call nitrogen fixation is the process of converting nitrogen from the air into a form that the plant can absorb ammonium. And it can be done in different ways. What we call industrial fixation is also the Haber-Bosch process. It's the way by which we synthesize nitrogen fertilizers, synthetic fertilizers. And as you know, in our current agriculture, it's a major source of nitrogen in the cropping systems. I don't know if you know, but when you have lightnings, you also have a bit of fixation happening. That's what we call atmospheric fixation. And today I'm going to talk about biological fixation, which is done by bacteria. As you know, some of our crops, like legumes in particular, are really good at associating with these nitrogen-fixing bacteria. Unfortunately, when it comes to cereals, their associations are really poor. And our cereal crops get very little amount of nitrogen from nitrogen fixation. And that's really what I wanted to try to tackle. In terms of numbers or the different type of fixation that I just mentioned, atmospheric fixation, when you have lightning, you see it's about 10 million tons per year on the Earth. So it's rather limited. Biological fixation on terrestrial systems, estimate between 90 to 140 million tons per year, mostly done by legumes. And industrial fixation, according to the number I found for last year, is about 170 million tons per year. And so you see now that we basically put more nitrogen on land than all the biological fixation happening with legumes in particular. So that industrial process, the Haber-Bosch process, our synthetic fertilizers, are first, I would say, a good thing, and we need them in our current agriculture because we need them. Here, that graph represents a very simplified graph from that paper, but we are basically showing here the increase of the world population, and here in blue, that's the proportion of that population which is fed, sustained with synthetic fertilizers. The process was invented at the beginning of the 20th century by Haber and Bosch, but really its use started to be intense during the Green Revolution. And these days, we estimate that about half of the world population is sustained through synthetic fertilizers. As a reminder, these synthetic fertilizers, the energy to perform that chemical reaction of converting dinitrogen from the air into ammonium comes from natural gas. And so we are using natural gas, a non-renewable resource, to produce the energy to produce these fertilizers that we then use to grow our crops for food fiber, feed, and biofuel. So if you remember what I just told you before, that half of the world population is sustained with fertilizer, what that really means is that we are really feeding half of the world on natural gas. That, I think, should be a concern for the long term. When you think that we are now using fertilizers to grow crops to produce biofuel, I find it almost funny that we use natural gas to produce biofuel. Obviously, that's not inefficient. But these are, I would say, long-term concerns. In the short term, the fact that we rely on natural gas to produce these fertilizers means that the cost of these fertilizers is highly dependent on the cost of natural gas. And I'm sure that you're all aware that in 2022, due to the war in Ukraine, there was a spike in the price of natural gas, and that led directly to a spike in increase in the price of synthetic fertilizers. And that, of course, affects also the price of corn. Another issue linked to the shorter-term issue due to the use of these fertilizers are environmental issues. And I'm sure that you have heard about nitrate leaching, the pollution of the degradation of streams of underground water, and then eutrophication in streams, river, and the Gulf of Mexico. The dead zone in the Gulf of Mexico is a direct consequence of our intensive use of synthetic fertilizers. So that's why, and actually for quite a long time, for more than 100 years, scientists have tried to take more advantage of biological nitrogen fixation. So when it comes to legumes, it works great. And as I said, I'm a bit skeptical about our possibilities to really improve that in legumes. But when it comes to cereals, there have been different approaches that people thought about over the years. The most, widespread idea is to take the legume system, these nodules, root nodules that we find on soybeans and alfalfa, and to engineer that system in cereals. There are still people who are trying to do that. I have a project funded by the Department of Energy to do that, but it's really long term. Another good idea, but also really long term, is the idea of taking the mechanisms of the bacteria that help the bacteria fix nitrogen and put that directly into plants. Plants that would fix their own nitrogen. No need for fertilizer, no need for bacteria. Great. And there are actually several colleagues working on that. Chris Voigt at the MIT or Luis Rubio in Madrid. They're all working on that, but it's super long term. There are lots of technical issues to solve. We are really far from there. And so I was interested in shorter term solutions to try to deliver nitrogen to cereals. One approach that we follow in my lab is to take the bacteria, isolate bacteria from, mostly for me, it's going to be corn and sorghum, and then genetically modify these bacteria to make them to fix more nitrogen and to release that nitrogen to the plants. I'm not going to talk about that today, but I'm happy to talk about that if you're interested. The approach I'm going to talk about today is the approach on the plant side, trying to see if there is any natural diversity, any mechanism that works already in cereals. And for that, my project started with corn by looking at natural diversity in corn. And so for that project, that's what I'm going to talk about today. So that project for me started with working with a company, the Mars company, the chocolate bars, and they funded a project to scout for natural diversity of nitrogen fixation in Oaxaca. And that's what we did, surveyed all Oaxaca. We actually even surveyed elsewhere in Mexico for corn that would show sign of potential better nitrogen fixation than the corn that we're using. And fairly rapidly, actually in the first year of the project, we got very encouraging results from one village. That village is called Totontepec, Villas de Morelos. It's in the mountains of Oaxaca, in a region where they don't even speak Spanish. They speak Maize, that's their native language. And in these communities, they grow corn on the slope of that mountain in a soil which has very low levels of nitrogen, and they grow continuous corn for more than 10 years without any fertilizer input. So that was a bit unusual to have that beautiful corn growing with zero inputs at all. And another feature of that corn is that it's a giant corn, so giant variety. So it's 15 to 18 feet tall. So if you know corn, you double the size. That's the size of that corn. It's twice the size of what you would call a tall corn. And these people here, they're not kids, they are adults in the field. So you see, like 15 feet tall. It's also, of course, it's a tropical region, so it has a very long growing season. So they plant in April, harvest in November. And as I said, their traditional way of growing corn in Totontepec is continuous corn, more than 10 years the same plot, corn year after year, no fertilizer, no input, and still they get their beautiful corn. So that was a bit unusual. And so the project started in 2009 for me. We got the first data from many places in Mexico in 2010. And the data in red are those from the first year, where the data came back suggesting that using a technique, it's called 15N natural abundance. And so that's what Pablo Zamora, the postdoc on the project, was doing. In 2010, the data came back from the village of Totontepec showing that in this corn, according to that technique, which is not perfect, half of the nitrogen was coming from the air. And so that was a bit surprising or very surprising. We were like, no way. So we said, okay, Pablo, go back to Totontepec. That was our most promising location. And so actually he lived in Totontepec for 3 years with his family. And so in 2011, 2012, he took more measurements over the season. And what he confirmed is that for about 4 months during the season, that corn is getting about half of its nitrogen from the air without any synthetic fertilizer. And so at that point, we are thinking that's unusual. To be honest, I was still thinking it was an artifact because an issue with the technique. And so we basically got seeds to Madison to do more testing. Before I go further, a feature of that corn that is really unusual when you see it, it's not only 15 feet tall, it has also all these roots on the stem. And so at every node up to about here, you get roots on the stem. You may have seen these nodal roots at the base, you know what we call the brace roots. They help for anchorage of the plant, they prevent lodging and so on. But usually, I mean, in the corn that we grow here, you have 2 or 3 nodes at the base, not more. There you get 10 to 12 nodes like that with roots. So you get roots up to here. And when it rains, these roots produce a gel. Sometimes we call that mucilage. That's a fancy French term or fancy term. It's basically a gel. They produce a lot of gel, about 1 milliliter of gel per root. So when we got the corn here in Madison, then we started doing some testing for how much we call that nitrogenase activity of the enzyme that in bacteria helps, allow nitrogen fixation. What we found is that in leaves, stems, underground roots, or these roots before rain when they are dry, we detect basically nothing. A little bit here underground roots, but it's really tiny. And in the roots that are covered with mucilage, we detect massive level of fixation. And so that activity here, by the way, is the activity for just a single root with 1 ml of gel on it. To give you an idea, I'm sure that 6 nanomoles of ethylene per hour don't tell you anything, but that's the same activity that I get with an alfalfa plant and all its nodules. So that's the level of fixation. So when I saw, okay, 6 nanomoles of ethylene per hour, that means it's like 1 alfalfa plant on a single root. That's a lot. So there we started using other techniques. In fact, we used all the techniques that are known that we can use to evaluate nitrogen fixation. We use them all, and all that is published in our paper from 2018, and showing basically that, yep, these plants are getting a lot of their nitrogen, about, I would say, half of their nitrogen from nitrogen fixation, from biological nitrogen fixation. I wanted to show you something which is not published yet, which is the fact that the same trait exists in sorghum. As you know, corn and sorghum are actually in the same clade of plants, and there was a hint of that. There was a cover page of a conference in 1986 where my colleague showed these sorghum roots covered with gel, showing that as in the cover page of that conference that was held at the ICRISAT in India in 1986. But if you open that book, there is nothing. There is not even an abstract. There is no paper published. And so I called him, his name is Dr. Wani. I said, why did you put that on the cover page of that abstract book? He said, oh yes, we had preliminary data, but we ran out of funding, and the project stopped in 1986. So in 1986, they did have some data already, never published, that there was a lot of fixation going on in the gel on sorghum roots. So I started working with them in 2019, and we got some accessions of sorghum that basically have exactly the same trait. We got some, now a project funded by the Department of Energy, and it's a collaboration with Dr. Wilfried Vermeris. But basically, that's the same trait in sorghum. It's in corn and sorghum. I'm mostly going to talk about corn today, but sometimes I will say a few things about sorghum, because now we always compare corn and sorghum. But both corn and sorghum have the same trait. So nitrogen fixation is done by bacteria. And the question that we had is, okay, that gel that supports that nitrogen fixation in corn and sorghum, how similar or different are the bacteria in that gel between corn and sorghum? And so we have techniques to evaluate what kind of bacteria is there based on DNA, called the amplicon sequencing. And so we looked at what we call the microbiome, or the microbes present in the mucilage of corn here. So that was actually at West Madison, nearby, and sorghum here at West Madison. And so you can clearly see with these dots being away from each other, that the community, the type of bacteria you find in the sorghum mucilage and corn mucilage is actually quite different. And here that's sorghum grown in Florida with my colleagues Wilfried Vermeris. And so you see that the sorghum mucilage, whether the bacteria in the sorghum mucilage, whether you grow that sorghum in Wisconsin or Florida, is sort of similar, distinct, but more similar than the kind of microbial community you find in the mucilage of maize. So conclusion here, you find sorghum and maize select for different communities, and of course location has an impact. So that's what I said already, location has an impact, it's highly expected, it's classical. And in terms of bacteria that we find, about more than half of the bacteria we find in both corn and sorghum and across location are called alpha proteobacteria. So what we think in terms of mechanism, how that gel works to support nitrogen fixation, is first we have that complex polysaccharide. That's the structure of the polysaccharide of the gel, of the sugar in the corn mucilage. We think that the degradation of that long sugar into simple sugars helps feeding bacteria. So bacteria to fix nitrogen need a lot of energy, and that we think that that energy comes from these sugars coming from the disassembly of that long polysaccharide. The fact that that gel is very viscous helps slowing down oxygen diffusion, and that provides a low oxygen environment inside of the gel. And I don't know if you have seen the legume system, the nodules. You know, when you squeeze them, you have a little bit of, it's called leg hemoglobin. That's the same goal. The goal of that leg hemoglobin in a soybean nodule is the same, to provide a low oxygen environment for the bacteria to fix nitrogen. Here in that system, there is no leg hemoglobin. The viscosity allows to achieve that low oxygen environment. And then the last part of the trick in that system here is that the gel is literally sitting on the surface of a big root. And these roots keep pumping nitrogen out of the gel. So as soon as the bacteria release nitrogen, it's taken up by the root very efficiently. I can show you here data showing that the polysaccharide is fairly quickly degraded into simple sugars. We measure the amount of simple sugars in the mucilage as soon as it's produced. And here it's about a few hours after mucilage production, when it's still sitting on the root, and we see much more simple sugars released. The kind of sugars that we find in that mucilage is similar but not identical between the maize and the sorghum mucilage, with a lot of galactose. That was the backbone of the polysaccharide, but also arabinose and fructose. And again, we think that these sugars help fueling, giving energy to the bacteria to fix nitrogen. So mucilage production is obviously a key parameter for the trait, and we wanted to find proxies of things that correlate well with varieties that fix a lot of nitrogen and produce a lot of nitrogen. Something that we noticed quickly when looking at these plants is that their aerial roots or nodal roots are very thick, much thicker than the nodal roots you get in accession that we use here. And we took many varieties, and we see a very strong correlation between thickness of the root, volume of mucilage produced, and how much fixation they can sustain. In other words, the thicker they are, the more gel they produce, and the more fixation you have. Fixation also happens in the youngest roots. So here, that's a young root, which is, you see, like a quarter of an inch long. That's what we call stage 1, and then the roots elongates, and it comes to that point where sometimes it's getting more brownish, and it's stage 3. And so we quantified the volume of mucilage produced by these different roots, and what you can see here, that's a root, and that's here the gel it produces. So younger roots produce the most gel. And so that's probably why the fact that these plants keep producing new roots on the stem allows for producing more and more mucilage. So the ability of these plants or these varieties to keep producing nodes with roots like that, and so new roots, short roots during the season, is a key factor, a key aspect of the trait. In all the varieties that we grow here in the US, these roots, these nodal roots, are only produced at the juvenile stage. It's almost actually even used by many people as a marker of the juvenile stage. In these varieties, the feature is that they keep producing these roots at the adult stage, up to tasseling time, and sometimes even after tasseling. So we think it's a key feature of these varieties is their ability to keep producing these roots at the adult stage. And that allows a high number of nodes with roots. In case you're wondering, we tested humidity. What's the impact of humidity on the trait, because it's coming from the tropical region. So we have tested growing this corn, both the classical XPVP from here or the accession with the traits under low and high humidity. Humidity has actually a very limited impact on aerial root development. I could dwell on that if you want, but we also looked at nitrogen levels in the soil. We were wondering if having more nitrogen in the soil would affect the trait, and basically it has no impact. So initially we worked on corn coming from a village which is here in Totontepec, and then we realized that the trait is not unique to Totontepec. It's actually present in many other locations in the mountains, in the Sierra Mije and other parts of that mountain range here, but it's also in the lowland near the sea. So it's not unique to that location. And here what I'm showing you is just one aspect of the trait, which is the number of nodes with aerial roots. All these are coming from, so the red ones are coming from the village of Totontepec, where we started working, but all these are coming from neighboring other locations in Oaxaca, so it's not unique to Totontepec. And the last one here, the blue one that I'm showing here, it's called Teosinte. That's corn pre-domestication. And so the trait is actually even in corn before domestication. All right, I wanted to show you a little bit about what we've been doing in terms of genetics. We developed different types of populations to find the genes that control the trait, different aspects linked to the trait. Here I'm showing you what we did with doubled haploids. And so we started doing our doubled haploids with an XPVP called, well adapted to here, which is PhD 51. And we used 3 landraces as parents. We developed 8 double haploid populations. And here I'm showing you data for 2 of these populations, population 1 and 7, because we have phenotyped these ones in both Wisconsin and Georgia in 2023 and this year in 2024. And so I can show you data on that. Basically, we think the PC1 corresponds to the PhD 51 contribution, and then PC2 and PC3 are basically correspond to the landrace parents. Again, the kind of phenotypes that we care about, that we measure, is number of nodes with these roots, diameter of these roots, because again, the thicker, the more gel they produce, and also we measure stalk diameter and many other classical parameters. In terms of heritability of the trait, the number of nodes with roots, root diameter and stalk diameter have an heritability which is okay. The total root number, moderate, it's not that great. Correlations, well, maybe I don't know if you're interested, but basically there is no correlation between the root diameter, the diameter of these aerial roots, and the number of roots. But we find a small, not fantastic correlation between the number of nodes with roots and the total root number, which makes total sense, and between the root number and the stalk diameter. Basically, the thicker the stalk is, the more roots we find. In terms of QTLs, we are making good progress. Actually, that we have data from that population, but also other populations, and we find some interesting QTLs that are basically linked to the trait. Here, in particular, I wanted to show you for that one here, number of nodes with aerial roots. Here, the region is huge on chromosome 1, but we have a major QTL, in particular on chromosome 1, that is associated with the number of nodes with roots, and that basically QTLs on chromosome 1 keep coming with different populations. In terms of breeding, I just wanted to show you some fairly recent data on breeding. So we developed different hybrids. So to evaluate the trait, we evaluate in corn, we evaluate the trait on hybrids. And so we had different crosses that we made between XPVPs and some tropical accessions, and some were back crosses, some were selfing, and we crossed them to testers. And so we had these hybrids, we made these hybrids with the trait, and we had control hybrids without the trait. They are not ideal controls, but that's what we had at the time. And this year, we evaluated the yield of hybrids with the trait and without the trait under either very low nitrogen or very low nitrogen. And we did that at Hancock. And for the low nitrogen, we reduced by 40 pounds per acre. For very low nitrogen, we reduced by 80 pounds per acre. And when we look at the yield, first, before the yield, we looked at, we took spad meter measurements for chlorophyll measurements. Okay, that figure is very recent. We'll improve it. So Rubens, who is here in the room, is the one who actually did these experiments. Okay, the first two columns every time in all these, so these are the different pairs of plant with the trait and without the trait. So we had 9 different pairs of plants with the trait and without the trait. So here the first two columns every time are the plants without the trait, the control, and no, sorry, no trait. Yes, the plants without the trait. And here the last two are the plants with the trait. And the first one, that's low nitrogen, second one, very low nitrogen every time. So here it's no trait, low nitrogen, very low, trait, low nitrogen, and very low. And what we saw already by looking at chlorophyll measurements during the season is that for some of these pairs, the plants with the trait had a much more, basically a higher chlorophyll content consistently even under low or very low nitrogen. So we did that at R1 stage. We did again, same at R3 stage. We were glad to see that these trends were continuing, that if you take here, for instance, with a plant, if you compare the plants that no trait or trait under low nitrogen, you have a strong increase in chlorophyll content. Here it's no trait, very low nitrogen, and no trait, and trait, very low nitrogen. We have that increase repeatedly. And of course, we took the yield. And so that's how Rubens basically estimated the yield. He measured the weight per plot. He evaluated the grain moisture to try to basically get a corrected weight for a standard grain moisture content. And then he corrected the plot size to estimate the yield, because that was, we basically had only had 2 rows and replicates of 2 rows only. So it was a relatively small scale trial. And what we saw is that we are very excited to see that again, that's the here that's the plant without the trait and with the trait under low nitrogen, and here that's the plant without the trait and here with the trait under very low nitrogen. And as you can see with the plant with the trait under low, again it's minus 40 pounds per acre, under or very low minus 80 pounds per acre. Consistently, the plants with the trait have a higher yield. And we get that in several of our pairs that we were comparing. That one here, he put a little gold because gold medal, that's our best pair. So these are primary data, again, from just coming from, when did you harvest? 2 weeks ago? 10 days ago?
1 week.
So very fresh data, primary data, suggesting that the trait allows us to get a better yield under reduced nitrogen inputs. So what are we doing now? Well, again, summary of what we are doing here. We are working on figuring out the genes controlling the trait. As I said, we are doing more QTL. I just showed you briefly what we are doing with the double haploids, but we have other populations, and we are excited to see that the QTLs actually match pretty well between our different populations. In particular, for the number of nodes with roots, we are continuing our pre-breeding effort, just insisting that what we are doing now is still pre-breeding. If you looked at the numbers, we are at like 3-4 cycles, and we are planning to reach at least 6. Self and back crosses. This side. So we are still at the pre-breeding stage, but I think we are exciting data already showing that it seems that the trait can allow the plant to grow under lower nitrogen inputs. We are looking at the molecular level. What are the cells really controlling the trait? There are the cells that we call border cells at the tip of these roots. And of course, we are trying to understand better, to improve the techniques to evaluate nitrogen fixation in the field. One aspect that I'm not going to talk about today is that my lab is also working, as I was saying, on engineering the bacteria and genetically modifying the bacteria. And so really our goal for next year is going to try to combine both technologies. The plant technology, the plant trait with these roots on the stem, and bacterial technology with the genetically modified bacteria that fix more and give more nitrogen to the plant. I've never so far combined the two. My hope is to be able to bring together the two next year. All right, I'd like to finish and acknowledge people in my lab. Oh my gosh, I forgot Rubens. You're not on the picture, but Rubens is here. He's the corn breeder in my lab, working very closely with Natalia De Leon in particular and Shawn Kaeppler. And Natalia and Shawn are my main collaborators for the breeding. Claudia Calderon also helped me a lot for basically the trait is coming from Oaxaca in Mexico, and we think it's important to try to give them some credit for using a trait that they have identified and selected probably for hundreds of years. And my main collaborator in Georgia is Jason Wallace. He's a corn breeder too. All right, thank you very much for your attention. I will be glad to take your questions.
Does that mucilage or whatever it's called?
Gel, mucilage.
Mucilage, does that have any nitrogen value, or is it just sugars that's leaking out?
It's mostly sugars, yes. Actually, there is very little. We were surprised initially when we quantified how much nitrogen is in the gel. Yeah. There is very little nitrogen. And then we realized, oh, but it's sitting on the root. And the root keeps pumping nitrogen out of the gel. So the gel is actually low nitrogen content. It has actually fairly low, because the root keeps pumping nitrogen out. We even looked at the genes in the root that are expressed, and these roots overexpress the nitrate, ammonium, and peptide transporter. So the roots do everything they can to get nitrogen out of the gel. So the gel is mostly sugars, yeah.
Now, if you put that gel on wheat or dripped it on oats, would that cause the plant to absorb?
That's a great question. So we were wondering, because in the field the gel drips, and we looked at the soil right under the corn, seeing do we see any fixation in that soil that has basically plenty of sugars, and we saw absolutely nothing, zero nitrogen fixation. And probably because our hypothesis is that as soon as it touches the ground, you have all the microbes of the soil that start degrading it. And so the fact that it's literally sitting in the air helps keeping that gel for about 2 or 3 days. You know, when it rains, so without rain, the gel does not come out. The gel comes right when rain falls on the root, and then the root produces about 1 milliliter of gel, and that gel is going to stay and then shrink slowly. And so after 2 or 3 days, it's just like a white powder on the surface of the root until it rains again. And so the fact that the gel stays on the root is part of the trick, I think, because otherwise in the soil it's degraded very quickly.
More questions?
Was that something that you could treat plants with, roots with, as an inoculant of some sort, or?
I don't think so for the same reason. I think that if it doesn't stay in the air,
yeah,
it's going to be degraded very quickly. We did a lab experiment where what we did is we took the gel from the corn and we put a plant called Brachypodium. It's actually very close to wheat. It's like a small grass. And we showed that the grass was able to get nitrogen from the air through the gel, but it was totally artificial. It was like we took the gel and literally put the plant and the roots of that Brachypodium plant were inside of the gel. Sure, it works. But in a field, my guess is that gel is going to be degraded very quickly by the soil. Yep.
I guess I got 2 questions. I couldn't see all the little text in the back. What were the bushel yields that corn was getting?
Yeah, that was very low.
It was low?
But it was first, I don't know if you know Hancock.
Yep.
It was corn at Hancock, and we reduced the nitrogen level by 40 or 80 pounds per acre. So the year it was about 70 bushel per acre. We were hoping for, I mean, that's what Rubens was telling me before the meeting. He was hoping to reach 100 bushel per acre, but again, it was Hancock, and as soon as it rains, all the nitrogen gets leached out, and we were reducing the nitrogen inputs to begin with. So, yeah.
So this is kind of a fine line with this plant, because, as I understand, like you wouldn't want to grow this corn in like really dry or like low humidity, because then mucilage isn't getting produced. But then you made it sound like if it rains frequent, then it just keeps washing it off.
So rain frequency matters. Yes, we need rain frequency at ideally once or twice a week is ideal. Less, the trait would not be great. Humidity actually does not matter. That's what I wanted to show. I showed maybe too briefly. So humidity actually doesn't matter so much. What matters is you need rain to fall on the plant to trigger the production of the gel. So rain frequency matters, humidity does not seem to matter very much.
And I guess my other question is, what's the projection of this ever getting like into a farmer's hands? Like to have corn?
That's our goal. I mean, our goal. So here we are. The goal with Rubens is to develop pre-breeding material that then we would basically be able to distribute to companies that who will be interested in taking that material and put it in their breeding program. So our goal is the Midwest. Is clearly to be able to put that trait in the hands of growers. I think that trait will also be nicely complemented with inoculation with bacteria, because if you grow that corn in a field that has never seen that corn before, well, the recruitment of bacteria from the environment is pretty inefficient. So my guess is that in practice, my hope would be to deliver better corn with that trait and together with bacteria that would help maximize, just like what we do for soybeans, frankly. I mean, I don't think inoculation would, if we keep using that corn for a long time, inoculation may not be necessary every year, but I think at least the first time for sure, inoculation would be necessary. So that's how I envision that is.
And with this, maybe I'm just asking, anyway.
Go ahead.
I'm just trying to wrap my head around this. So like, are you guys also looking at this for like corn silage as well? Or is this only gonna be limited to grain production?
It's just that I don't have enough hands.
Right.
Like Rubens is the only breeder in my lab to do that. So currently we target grain, but silage or I mean, I was talking with Bill Tracy. Would that be interesting to do that in sweet corn? I've never did it. I just literally Rubens is the only person in my lab doing it. So.
Well, I was gonna say, because that's where my mind went, was it's like, well, if you got low yielding corn but it grows big and it can sustain itself like that would make it like, and if it feeds well, that's one option. But I didn't even think the sweet corn thing. That'd be pretty cool too.
Also have the inbred lines of the trait. It becomes easier to use the inbred line to transfer the trait for another inbred lines in a breeder program. Because it's really hard to deal with these Mexican land races. So if you start from the zero, the product is very, very challenging. So if you have one inbred line with the trait, we can use that to transfer and improve our pre-breeding program.
Yeah, the most challenging, frankly, were the first crosses we had to make between these giant tropical corn that takes 9 months to mature, and so to the point where my Mexican colleagues who tried to do the same, they failed, and they told me, no, it's not possible to cross it with varieties adapted to the US. Well, it's possible, just took a lot of effort at the beginning, but now, now we still need to do we need to first finish the pre-breeding, that's what we're doing now, and hopefully, I would love to put that in the hands of growers here. That's the goal.
And with the ladder?
No, without the ladder, because the size now is normal.
Okay,
we were able to get rid of the size.
Well, that would work for the silage part if you could keep it big enough.
Are you gonna have that corn in Hancock again? Is that where you're?
So if everything goes well, next year we'll do Arlington. One advantage I have with Hancock is the ability to control nitrogen easily, because it's I can do easily low and very low field nitrogen trials at Hancock. With Arlington, at least the first year we'll have to deplete the field for nitrogen to be able to reach lower nitrogen levels in the soil.
Was Hancock irrigated?
Yes.
It was, okay.
Yeah.
And that would give you a frequency of moisture.
Yeah, exactly.
Theoretically.
Exactly.
Or Wisconsin gives more frequency than non-irrigated west because it doesn't rain as much west, but they can irrigate too.
Yeah, rain or irrigation, as long as you have water falling on the plant once or twice a week, you're good. And we tried, by the way, drip irrigation, like zero mucilage comes. I mean, if you just irrigate at the ground level, nothing.
Right.
You need water to fall on the roots.
And
but
again,
interestingly, humidity from the air does not really matter.
Interesting. Yeah, and again, for irrigation, a lot of times drip irrigation or down close is what they do because you lose your moisture when you throw it in the air.
Yep.
Interesting. And then the mechanism for us is, and our next speaker will give us some of that, is that we tend to be in crop improvement a mechanism to try to introduce this to places and collect maybe some royalties that comes back to.
And if you have ideas of things we should do or not do, I mean, I would be more than happy to get feedback. And again, Rubens is one breeder in my team doing that for, right now we do corn for grain, but I would love to be able to do more, yeah.
So we do have a function outside of small grains, and hopefully we can help
Be
within sweet corn.
I would love it.
And our next speaker will be potatoes, and he can give us a story on Snowden potatoes and how all that value went no place back to the breeder, right? Okay, any other questions? As always, thank you so much.
Thank you.
Okay. Very good. Our next speaker is Jeff Endelman, and again, we'll just go by potato breeder. There you go. And Shaminder and I had a chance to meet with the potato people here about a month or so ago up at Hancock, because there's a research facility there. And we got to observe firsthand how 18 feet of potatoes works in a storage bag.
Good. I don't have any pictures of that in my talk, but
Well, we understood that I played football in high school, not very well, but I can relate to the fact of if you get tackled and you're down low and you're at Belleville and it's on an island and it just got done raining, water kind of runs through your helmet. So you get this claustrophobic effect. Well, in potatoes, it's the same thing. You have 18 feet of potatoes. You need a potato that doesn't compress. And that's kind of important if you're going to store them, right? Otherwise, you just got to pick off the top ones. I know there was more information at that meeting, but I was able to understand that concept when we sat with a bunch of Bens.
okay.
Very good.
Right, yeah, well, thank you for the chance to be here. I guess I was looking back at my old file, so it was last year I spoke to this group in 2016. So I don't know if there was anyone here at that time. I figured there might be a lot of new people, so I do have some of the similar material, but try to also get into some new things that have happened.
But for old people, we forget anyway, so
right.
we'll all be new.
We'll all be new. Right, so my name is Jeff Endelman. I'm a professor and the director of the potato breeding program at UW. And just a quick little slides about the history of potatoes. Where do they come from in terms of the ones that we enjoy now? The potato was domesticated in the Andean highlands, so modern day Peru and Bolivia, somewhere between 8,000 and 10,000 years ago. If you go to farmers markets in those areas, right, you can open air markets, and you were to check the ploidy of potatoes in those areas, you'll find there are both diploid and tetraploid land races cultivated. And hopefully by ploid you have some idea what I mean. It's basically how many sets, chromosomes are organized in groups of chromosomes that pair up when sexual reproduction occurs, when the sperm and the eggs are produced, right? Humans are diploid. We inherit one complete set of chromosomes from mom and one complete set of chromosomes from dad. That's what, same thing with the diploid potato. But tetraploid potatoes inherit two complete sets of chromosomes from mom and two complete sets of chromosomes from dad. And there's a lot of interesting history and genetic study about how these different ploid systems evolved. If you look in southern Chile, they also have many hundreds, if not thousands of years of experience cultivating potatoes, but you only find tetraploid potatoes in southern Chile. And of course, being in southern Chile, at those lower latitudes, they have seasons kind of like what we do here in Wisconsin, right? They have long summer days and short winter nights. So in particular, those long summer days, that photoperiod, as it's called, influences flowering processes in plants and also the formation of tubers, which is actually the same pathway that is involved in how flowers are formed, was kind of through evolution modified to control how tubers are initiated, which are basically underground modified stems. They're not roots. So that's anatomically a bit about them. Anyways, when Europeans came to the Americas, of course, they didn't know anything about what was diploid, what was tetraploid, right? That was a science that was yet to be invented. And they undoubtedly brought many different kinds of potatoes back to Europe. And it turns out that if we look at our germplasm that survived hundreds of years of additional selection and cultivation in Europe, the genetic signatures indicate it was primarily the Chilean potatoes that were successfully able to adapt to the northern European conditions, and it's thought to be not because they were tetraploid per se, although that's a little bit of a controversial statement, but rather because of that already having that long day adaptation. They were already used to tuberizing, forming the tubers under the conditions of long summer days or short summer nights. Now, in the last 100 years, there's been a lot of effort to then go back to a lot of the more tropical germplasm to bring in specific genes that contribute to disease resistance in particular, because again, a lot of the pathogens that we deal with on a global scale have co-evolved with potato for many thousands, tens of thousands of years, and their wild ancestors. So that's kind of in a nutshell, big picture for potato breeding. How are potatoes propagated? Right? So when potato farmers talk about seeds, what they're talking about are actually pieces of tuber, right? When you go to the grocery store and you buy a potato tuber, every one of those eyes has the potential to sprout and grow a new plant. And so basically those are cut up and planted in the ground. Those are what the seeds are in your typical potato agronomy. Potatoes have very pretty flowers, which some varieties of potato will flower in Wisconsin, not all. But it's basically a trait that has no commercial value as it's widely understood. Right? Breeders don't select on flowering primarily, and that sometimes gets you in trouble because, of course, to do breeding, you do have to have flowers. That's how we generate new varieties of potato, is by intentionally cross-pollinating. And so it's often the case that I'll do some selections of potato and I put them in the greenhouse to make crosses, and they may be very poor flowering, or if they do flower, there's no pollen. We have a lot of male sterility factors that are floating around that we don't have a good understanding on. So it's a little bit of a double-edged sword in terms of how flowering and reproductive fertility is valued from a breeding versus an agronomy perspective in potato. And a key point of the fact that the whole agronomy and seed system is based on propagating essentially a stem, right, which is a modified stem, which is the tuber, is that it's a very good vehicle for transmitting disease. The process of forming the seeds, true seeds, in like grain, right, grain seeds, for example, that it provides a barrier to the transmission of most pathogens, not all. Some viruses can be transmitted through seeds, but in potatoes, there's just everything basically can be transmitted through the seeds. And so over the last 100 years in the US and in many other countries, they developed what's called the limited generation seed system. The name, as the name implies, it means that at any given location, you only propagate it by vegetatively or asexually for a small number of generations to prevent the buildup of disease. And you have kind of a hierarchy of cleanliness, starting from the most clean being the in vitro stock, which is how all potato varieties that are grown commercially are maintained as these small plantlets in an agro medium and under aseptic conditions, right? They're completely free of diseases that we can test for. And when there's an order put in that, okay, this farmer is going to want to grow some seed, well, okay, we start the supply chain, but it's going to take a couple of years before that seed's ready, because what has to happen? The first year, those plantlets are cut and multiplied, so you have many plantlets, and then they're put into a hydroponic system typically, which then they're harvesting those tubers from the hydroponic system. That takes about a year basically. Then they can put them into an elite foundation seed farm, and there's really only two, I think, basically in Wisconsin. They're both in outside the town of Rhinelander and Eagle River up there in a more isolated condition, so far away from the commercial production. Those elite foundation seed farms might grow for only 1 year or sometimes 2 years, but usually typically not more than 2 years. That's limited generations that they want to have to kind of get it out from their farm before there's a chance for the aphids to potentially migrate from the main commercial acreage. And that's really the main game here, is that we're trying to avoid the transmission through the insects of these viral diseases. So they may go from 1 or 2 years in Rhinelander to, again, 2 to 3 years perhaps in the Anago area, which is where some foundation seed and some certified seed is produced, and eventually they make their way into the hands of a so-called commercial grower, which would buy certified seed and then produce it for 1 year before it goes into the fryer or into the grocery store, right? That's the commercial acreage. So that's the limited generation system in Wisconsin, and many other of the major potato states have a similar type of arrangement. There's a seed potato certification program that is involved in the inspection of these seed lots. They do summer inspections to look in the field to see, do they see signs of disease or mixture, and then there is an elaborate winter test procedure. Actually, right now, the carton, the shipping crate of all the potatoes from all the seed growers in Wisconsin is making its way to Hawaii at the moment, and they're going to plant those potatoes there next week, and they will do a visual inspection of all of the daughter tubers from that seed to try and check before we plant all those seed tubers next year in Wisconsin. It's a chance to check them in Hawaii after they've been treated with a chemical to help break their dormancy, as again to try and keep the levels of virus down in our seed system. So, pivoting now to talking about potato breeding, which is really my specialization, there are a large number of potato breeding programs in the country. I think wheat is the only other crop that has a comparable number of public sector breeding programs. There are 11 university-based breeding programs. There are 4 breeding/pre-breeding programs within the USDA Agricultural Research Service, depending on how you exactly define that. You can see Wisconsin's one of the lucky states that people don't realize. We have a private breeding company, that's the Frito-Lay breeding company based in Rhinelander. We have the UW breeding program, which is the one I direct, and then we also have historically had a USDA breeding/pre-breeding program. That position is currently vacant, but we're hoping that they will refill that position. So we have a long tradition of potato breeding here in the state of Wisconsin. And if you look at where the breeding programs are located, they basically mirror where potatoes are grown, right? So Wisconsin is the 3rd largest producer of potatoes in the country. The number 2 producer is the Columbia River Basin, which straddles the Oregon-Washington border. And of course, the number 1 state for producing potatoes is in Idaho, and there's a lot of both private and public breeding now in Idaho. The UW's history goes back to 1936. That was when the first potato breeder was hired. In 1948, the potato breeding farm was established in Rhinelander, which has a little over 10,000 square feet of high tunnel space for mini tuber production. We have a little over 100 tillable acres, and the key thing is you got to have a big storage facility. I still remember when I interviewed for my job, I was pulled aside and I was a small grains breeder when I did my PhD. I'd never worked on potato before, and my predecessor wanted to make sure I understood just how much bulk there is in producing potatoes, right? Our breeding program has access of storage that can store 250,000 pounds, which is still small by comparison to what, a commercial storage, of course, is an order of magnitude, 2 orders of magnitude bigger than that. Anyways, it's a very picturesque place up in northern Wisconsin, and Rhinelander nestled in among the pine trees. Of course, right, if you don't know the history of how potato production ended up in Rhinelander, at least the story is told to me, is that after they cut all the pine trees down, unfortunately, to export them for timber, they tried to figure out what are we going to do with all the open space, and they found, okay, potato seems to grow well here. It likes that acidic soil, sandy soil. That's a very good soil for potato production. Hence, the potato industry of northern Wisconsin was born. We have many different market types or product profiles, right, which you're familiar with if you've ever gone and bought potatoes at a grocery store. We have red potatoes, we have yellow potatoes, we have russet potatoes. You don't see very often these round white potatoes. Out east, they still have a kind of fresh market, but most of the rest of the country, those round white potatoes are only used to make potato chips. And the russet potatoes can be used both for fresh market or baking, roasting, but also for the French fry processing, which is a major industry in the United States. All right, a bit about how does it work. As I mentioned already, the beginning of potato breeding to create a new variety goes back to playing the role of the bees, and so to speak, right? Potato is naturally insect pollinated by bumblebees or relatives of bumblebees, and so we are cross-pollinating the individuals we want to be the fathers to the individuals we want to be the mothers. You can self-pollinate a potato plant. You will, generally, it's rare that you can develop any commercially viable varieties out of a self-pollination, just because of the inbreeding depression that potato experiences as it becomes more, as the parents are closely related, and of course, the same individual is as related as it gets with itself. So we generally do out-crossing as opposed to self-pollination in our typical breeding schemes. The fruit form look like little green tomatoes, and inside them can be hundreds of seeds. They're pretty prolific, and each one of those, these are now what we call true potato seeds to differentiate them from the seeds that the farmers grow, which are the tubers, of course. So these true seeds, each one is genetically unique. It's just like animal breeding or human reproduction, right? Every potato is very genetically distinct from each other. They're not inbred, and so when they mate, all the offspring are all genetically different from each other as well. And so the job of the potato breeder is to sift through all those genetically distinct types and find, hopefully, the next commercial variety. So a typical breeding program produces maybe 20,000 to 80,000 new potato varieties each year. It's a number that still is mind-boggling, right? In the United States, there are 1 million new potato varieties generated each year. And of course, 99% of them are thrown away very quickly because they don't have the characteristics needed to become successful. But that's the process of the breeder. The exact number varies depending upon how many different product profiles you're breeding for. So I typically say 20,000 is a good number for one product profile, like potato chips. If you breed for potato chips and French fries and red potatoes and yellow potatoes, you need 20 plus 20 plus 20 plus 20. And that's how you get to numbers like 80 or 100,000 each year. When we grow them in our high tunnels, this is what they typically look like at the end of the season. You may have some pots that have 0 tubers and some that have 4, but the traditional system of potato is that you take a single mini tuber out of each one of those pots, you put them all together from all the other siblings that all have the same parents, and you've got a big bag. We call it a family bag, right? Every tuber in that bag is a different offspring with different genetics. And we just put them in the ground, one tuber every 3 feet in a 2-row planter. The Iron Age planter, right? It's a design that hasn't been improved in a very long time. And at the end of that season, the breeder walks up and down the field, and we've lifted with a 2-row bed lifter all the tubers up out of the ground, just drop them on the ground, and you spend about 3 or 4 days just walking up and down that field. Again, the 40,000 plants, every 40,000 plants, every one of those plants in that field is genetically different from each other. And it's a beauty contest, right? And the first time you do it, it's just mind-boggling how bad it can be. I mean, these are some of the extreme examples, but they're by no means uncommon, right? This is, if you're making a russet variety, this is what you want. They have to have the right length to width ratio. They have to look like a russet potato. The eyes can't be too deep, right? You don't want these kind of eyebrows, as we call them, bumps around the eyes, which all these things, right? So here's horribly cracked skin. Here's the knobs that can form. These are, again, typical defects. So this is just, it's a visual selection in that first stage, and even just based on those very simple characteristics, which are highly heritable characteristics, okay? Usually selecting on one plant is a little bit dicey, because how do you know if what you're seeing is just some influence, you planted it in a bad spot, right? Then it's not a genetic characteristic, it's just a bad spot in the field. Well, the accumulated wisdom is that many of these characteristics we're talking about are not due to a bad spot. You don't get this kind of knobbing just because there was a mouse that pooped right there or whatever, right? So that's a genetic problem, not an environmental problem. We don't really select on, there's not really yield. Of course, if there's no tubers, that's a problem that takes care of itself. But we're not really selecting on yield per se. It's mostly these appearance traits and the maturity. Do you have a green tree after 2 applications of dicot, right? We apply typical potato production involves 2 applications of the herbicide dicot to even get the plants to finally mature at the end of the season. That's normal, but even after that, you can still see plants that are this tall and they're totally green, right? Because they don't even have, they haven't naturally approached the end of their life cycle, so they don't really respond to that herbicide application to finish their life cycle. Anyways, so you can go from 15,000 down to something like 750, even just based on 2 very simple traits. And now things start to get a bit more interesting. Now we've kind of eliminated a lot of the obviously bad varieties, and now we're trying to look for more agronomic characteristics. So now we look a bit more. In the second year, we have 8 plants, right? Because we picked up from these 2 russet potatoes, I can easily get 8 seed pieces out of that. That's, there's probably 15 eyes with 2 ounces of tuber tissue around it, easily to get 8 seed pieces. And now, that season again, it's kind of a lift and drop type of operation. But now I'm looking at how many tubers are there, what's a rough estimate of yield, the tuber size, characteristics, et cetera, et cetera. Yeah, you have a question?
Question, with that combine or what, on the outside there's whiter, are those sorted, pre-sorted there already, or?
Very, very observant. Yeah, the way so this is a 1-row bed lifter,
Okay.
and to try and minimize the potential for potatoes to roll when they fall off the back end of the conveyor and they hit the bed, they can roll into the alley. And to try and prevent, if you were to just harvest every row, you would end up just having to have someone there always picking up behind it. And so we actually, every other row, we do the odd rows first. We go through and do the visual selections, and then we go back and do the even rows. So that's why you see a little bit different soil color because of the fresher, wetter soil versus drying out a little bit. So very, very, very observant. Anyways, one of the things that we've been doing the last couple of years, and this is where this picture comes from, is we now fly a UAV or a drone over our breeding trials on a pretty much 7 to 10 day frequency. And what we can easily do from that is to measure the development of the canopy of the potatoes. Unfortunately, you can't see underground through an aerial camera. There are people trying things involving ground penetrating radar that would drive kind of alongside the hill, right? Potatoes are, the dirt is mounded up over the potatoes to try and get higher yields, to get more tubers produced underground. So anyways, that's not something that anyone has access to in terms of a routine tool yet, but that is in the works. But even from looking at the canopy growth, we can see that if we correlate the, let's say, if you make a plot of, let's say, the aerial ground cover or canopy cover over time, and you calculate the area under that curve, which is kind of like how much light can the canopy intercept, right? You have to have a canopy to intercept light to do photosynthesis to then have those sugars move into the tubers. The correlation coefficient is about 0.3 to 0.4 between yield and the total amount of integrated canopy cover. So that means even before digging anything, I can predict which of these clones, as we call them now, has some tubers under the hill. Now, okay, a correlation coefficient of 0.3 or 0.4 is, that's not a huge number, but we can combine that with our genomics. So we also now, when we are cutting the seed to plant these trials, we now also take a piece of every tuber, extract DNA, and run 15,000 genetic markers on it. And that information is tying that individual back to a historical database where we have yield data on, at this point, 1,500 of its close relatives, right? Its parents, its grandparents, cousins, et cetera, et cetera. The combination of the marker-based predictions with these aerial-based image predictions, we're hoping can improve the accuracy of our selections. That's what we're working towards over the next year or two. Okay, let's move on into the selection process. From 750, we can again throw away maybe 80% or so based on a couple of those agronomic traits. That the first and second years are taking place at that Rhinelander farm, which is not a representative environment of that commercial site, which is in the central part of Wisconsin, right? It's a shorter season, not as extreme temperatures in terms of heat pressure. Anyways, now in year 3, we move on to the Hancock Station, which we just heard a bit about from Professor Anne, and this is the traditional irrigated vegetable region for Wisconsin. We have access to better equipment. We now have an optical grading system. We get a weight and a rough approximate length, width, dimensions of every tuber coming out of the ground, so we get really rich data, which is important. For example, the French fry industry and the potato chip industry actually want really different things in terms of the size distribution. Potato chip manufacturers say, we want every potato can you breed a potato where every potato is between 2 and 3 inches? The answer is no. You cannot make a potato like that, as far as we know. There's always a little bit of a distribution, right? So you want to try and get 90% or 95% of the distribution within those parameters, but there's always going to be some that are smaller or bigger. The French fry industry wants a much different. They want some potatoes that are 4 to 6 ounces. They want some that are 6 to 10 ounces. They want some that are 10 to 14. They want a whole range, because when they make French fries, they want some small ones, they want some long ones, etc. The same thing is true with fresh cartons of russets that go to food service or baked potatoes. They have cartons that are all of a certain size, but they have to have a mix of the carton sizes, the tuber sizes. So different goals depending upon what product we're talking about. We of course make a lot of potato chips. We make a lot of French fries to see how do they actually look. There are soil-borne diseases that are important. This is the most important for Wisconsin. It's a soil-borne bacteria, Streptomyces, and it's called potato common scab. Some other interesting traits that we look for, right? When you store potatoes are interesting because they have combined elements of like an agronomic crop, like a grain crop, but it's still a vegetable that you're harvesting, right? It's a different physiology. And the temperature, they're very sensitive to the temperature that you store them. Ideally, you'd store them at a cold temperature, because the colder you store them, of course, right above freezing, you slow down any diseases that might be present, the progression of the diseases, and the condition that you also slow down the metabolism of the tubers, so they maintain their condition longer. But one of the interesting things that happens is that potatoes, their natural physiology is that they convert their starches into simple sugars, and then when you fry those potatoes, those simple sugars react with amino acids, and they produce these dark French fries or dark potato chips. And the product specification is that we want light potato chips, we want light French fries. There's some, there's variation around that. Some people like a darker fry or a darker chip. But besides the aesthetics of it, there are actually certain compounds that are produced that you can't even see. Namely, acrylamide is the main one that people worry about, which is a carcinogen. So there are some things that are disadvantageous to having. The brown colors are indicator of things you can't see that you don't really want to be eating. Skin set, another interesting trait, right? That is unique to it being a vegetable, right? When the tuber is growing, the skin, right, it has to slip to allow for the expansion of that tuber. But at the end of part of what's happening at the end of the season, after that herbicide is applied, is that the skin is maturing, the physiology is changing. It's actually analogous to basically like, potato skin is like bark on a tree. The cork cambium, right below bark on a tree, has an equivalent meristematic layer in a potato, and that layer, which is called phelogen, kind of hardens and it cements that skin onto the underlying tuber tissue. But of course, the way that cement happens can be better or worse. These are pictures of two siblings, the same parents, and just by tumbling them through the harvest equipment, we didn't do anything more besides just harvest them, run them through the conveyor system, and you can see very easily with the red skin potato, genetic differences in terms of the delamination or the shearing off of that. So we've studied the genetics of that and have been trying to improve that in our potato varieties. All right, now looking at the whole scope of what's going on, right, as we get further down this selection pipeline, we get smaller and smaller numbers, the number of clones, and we're expanding the number of locations. The nice thing about having so many public potato breeding programs is that I can send seed tubers to Michigan, Wisconsin, Oregon, New York, all these collaborators. They test our varieties and we test theirs. So you get, in one calendar year, you can get data on 5 to 10 different environments, which helps you to make some very powerful selection decisions. After 5 years of field testing, we feel that we have enough information. We're typically down to maybe 5 of those first 20,000. That's not how much we've reduced it. And now we go to the trouble of actually putting those potatoes into tissue culture, because again, that's the starting point to producing foundation seed. And so it takes about 1 year to do that introduction to tissue culture. Then the following year, we order the mini tubers, but we've also cut some. So, right, if we introduce 5 to tissue culture, I've probably thrown away half of them already 1 year later based on new information. But I don't want to wait till I'm 100% sure because then I have to wait 3 more years before I have foundation seeds. So there's a trade-off there. How much money do you spend to start producing foundation seeds for things that you're going to cut, right? The time is money kind of a thing. So after 8 years, I say here 0 to 1. We're down to maybe 1, but sometimes of the 20,000, none. There were none that were good enough. That happens all the time. It's estimated that the odds of commercial success are at best 1 in 50,000. Some people will say 1 in 100,000, 1 in 200,000. It really depends upon your philosophy. But the point is that you have to have huge numbers to get commercial success. And so part of my job as a research scientist is to figure out how can we do better, right? If we just keep playing the same game, potato breeding is going to be kind of making the same slow progress that has made a lot of people, growers and the industry kind of, disappointed in how much we've accomplished. We still have extensive use of pesticides to grow our potatoes. Where's the progress in terms of getting better disease resistance, better insect resistance, better yields, et cetera, et cetera. But we're working with a breeding system and a genetic system that's very difficult to make progress. So how can we do better? My main focus for the last decade has been to do what's called genomic selection, a breeding technique that was pioneered first in dairy cattle 20 years ago, and then in corn about 10 years ago, and now we were the first public program to do it in potato in the United States. We started in 2018. It took me about 5 years. I started in 2013. It took me 5 years to finally develop the data set and the logistics to actually do this. I talked already a little bit about how in that second year we run the DNA extraction and then we get those 15,000 genetic markers. That's the information we need to combine with our historical data to build these large regression models that are predictive. Okay, it's not as impressive as like Amazon predicting what you want to order for Christmas, but that's the kind of general idea that we're talking about, right? Those kinds of statistical models. And the key point is that the rate of genetic progress is much like accumulating interest in a bank account. Okay, right? You can when you are investing your money, you look at what rate of return you get on that money. But of course, it also depends upon the time interval that return is realized. I mean, in the financial world, typically things are always reported on an annual basis, so it's always comparing. If you get 8% return on 1 year versus 10% return, you take the 10% return, right? Assuming you don't need to take your money out within the next year, right? In breeding, it's not quite like that because you have two things to think about. You have one, which is the rate of the percentage, like the interest rate, but that interest rate may take you 5 years. So and that's what we call the breeding cycle. The breeding cycle is basically the time it takes for you to identify individuals from that generation that you will use as parents to start the next cycle. That's like the annual cycle of generating interest on a financial investment. My predecessor, in general in potato breeding, would typically wait until they were already introducing new varieties into tissue culture before they would start to use them as parents, which means that it takes about 6 to, could be almost 10 years before they identify the offspring that have some improvement. They use them as parents, and they get that kind of feedback where they compound that genetic improvement over time. Well, what we want to do with these genomic predictions is that try and maintain the same percent improvement, whatever it is, 1% a year, 1% per cycle, or 0.5% per cycle, but instead of it being a 6-year cycle, make it a 4-year cycle. Then you get 1% improvement every 4 years instead of every 6 years. And what we're doing, actually, at this point, we're trying to achieve that in a 3-year cycle. We want to try and get the same level of improvement in terms of the yield, chipping quality, whatever it might be, on a 3-year cycle instead of a 6 or 10-year cycle. And that's what genomic selection is allowing us to do. Even with that, we're still going to be too slow, I think. We're not going to make the kind of genetic progress that we need to achieve our goals and the goals of the potato industry stakeholders. And it boils down to the fact that the tetraploid genetic system is just fundamentally recalcitrant to genetic change. It's just, even if you go faster, you're still working with something which has tremendous inertia. And that's really this whole shift between thinking about a tetraploid genetic base to a diploid genetic base, back to what I said at the beginning. Potatoes have been diploid for longer than they were tetraploid, not in a modern breeding system, but we know they are quite, they work quite well at the diploid level. And actually, tetraploid breeders have been doing diploid breeding on the side all along. all major potato breeding programs have a kind of side hustle with diploid breeding. It's just that they used to always take the diploids, cross them to the tetraploids, and release tetraploid varieties. They never thought it was feasible to just release the diploids directly to farmers. And the thinking about that has changed. There's been people who have said all along, that's wrong, no, you can be successful at the diploid level, but the conventional wisdom was that no, you couldn't. The conventional wisdom now is that yes, we can. And what's changed, one, is that we know a lot more about the genome of potato, and we can manipulate the genetics of potato better than we could before. But frankly, also there were a few people who just persisted long enough, and they proved to everyone else that yes, it could work. And there's in particular, there was a visionary tomato breeder from the Netherlands who, back in the 2000s, got germplasm from a Japanese scientist who got it from Wisconsin, and eventually founded a private breeding company. And people started to notice that actually, okay, there's something happening here. Then all the other Dutch breeding companies, which is the main, the biggest private breeding companies in the world, are all in the Netherlands. They started their own diploid breeding programs. Now Pepsi has theirs, and now we have our, anyway, so now pretty much everyone's got an effort to try and make a diploid variety. But it's different than the traditional land races, because it's not going to be an outbred, it's not going to be like an animal in terms of where you cross two diploids and every offspring is different. We actually want hybrids just like the corn hybrids are. We want inbred lines, and we want to be able to make hybrid combinations of the inbred lines to try and find the best hybrid varieties for the farmers. So that's what this whole paradigm shift that this table represents is. Right now, if you want to order a new variety, you go back, if a farmer says I want more seed of a variety, they go back to tissue culture. They have to propagate it, as I was talking about in the beginning of this talk. In the new system, if a farmer says that I want a tote of seed of this variety, we go back to the two inbred lines, we cross them, we make hybrid seed, something you're all very familiar with if you work in the corn business. That's what we want in potato. And we're getting there. It's going to be a slow, it's not like a 5-year horizon. It's like a 10, 20-year horizon. So this is something, hopefully by the time I retire, I can point to it and say, yeah, we've got some hybrid varieties. I will probably be the last tetraploid potato breeder at the University of Wisconsin, I would guess. If I stick around another 10, 20 years, I don't think the person who comes after me will even bother. They'll just be focusing on diploid breeding, because we're trying to build the infrastructure and the germplasm base to make that possible. So you start by, we have the best germplasm in the public sector in potato. It's all tetraploid. So first we have to get it into the diploid form. That's what haploid induction is. When you make, in corn, when they make haploids, you talk about taking a diploid and you have 2 sets of chromosomes down to 1 set of chromosomes. Well, you have a tetraploid, you make a haploid, you get 2 sets of chromosomes, right? The eggs are stimulated to basically turn into seeds without the father's chromosomes. So you have diploids, and now all of the public sector breeders have done this over the last 5 years. We have 100 diploids that we have made publicly available to the private sector, to other public breeders. We sequenced their entire genomes. All that information is available to try and provide a resource for future diploid breeding. My colleague at Michigan State University has been doing diploid breeding much longer than I have, probably 10 years. He's about to retire. He had the foresight a long time ago. He has some diploids, not hybrids, he just has more, I would call like these outbred diploids that yield almost as good as the best tetraploid chicks. So he's already been able to overcome a lot of the yield deficit we see when we go from that tetraploid to diploid level initially. We started to do some limited inbreeding, make some preliminary hybrids. There's still some segregation. Those are not good enough to be grown by farmers. But we can already start to see that we can tailor in maturity. We can create hybrids with different maturities, something that we could never do before in potato. It was always very baffling about how would you know what maturity. We now understand the genetics, and we can tailor that much more readily. This is a picture showing we bought a vegetable transplanter 2 years ago, and we actually figured out how to grow the potatoes in plug trays so they don't just fall out when you put them in the system. So it's just like a lettuce transplanter or a tomato transplanter, cabbage transplanter, whatever it is. we now are starting to do transplanting trials and figure out all the horticultural techniques needed to do this on potato. And of course, there's a lot of interesting questions for economists to figure out about what's it going to look like. I mean, everyone wants to know, okay, which farmers are going to grow what? Like, are we going to produce transplants and we won't have any seed growers anymore in the country? Everyone will just start true seeds? Probably not. That would require a massive greenhouse infrastructure, which doesn't exist in the country even, to produce that amount of potato transplants. You also have to tack on another 20 to 30 days of this growing season to be able to finish a potato variety that starts like that, compared to if you put a tuber seed piece. So in Wisconsin, probably couldn't do it. You know, maybe with climate change you can in 20 years, so who knows, right? Anyways, lots of interesting questions. What we predict is going to happen is that you're going to have, back to the kind of, dare I go back to the beginning, to the limited generation system, we predict that it's these seed growers up in Rhinelander that are going to have to be the ones to figure out how to grow transplants. They're going to grow transplants on their farms, and then it's going to kind of pretty much be like it always was, but instead of them getting their initial stock from a greenhouse system, they're going to contract with a greenhouse grower to grow them those transplants, and then they're going to put them in the ground. And they're going to have a very short season. They're going to grow a lot of really small potatoes, but even so, the economics of it looks like it's still going to be better. So here's the preliminary economic analysis we did with Paul Mitchell. This is what it costs under the current system to grow seed at different field generations. And it's based on the assumption, the current price for a mini tuber, if you order a mini tuber, which is, again, I mean, it's like it's like a quarter at best. That's what a typical mini tuber looks like now from a hydroponic system. It costs 55 cents for that seed piece. It takes 20,000 of them to plant an acre, roughly. This is you can see here the progression of the supply chain, as I was talking about earlier. Tissue culture plantlets become mini tubers, et cetera, et cetera. So at 55 cents per mini tuber, without putting in any any profit for the grower, it costs then $60 just to plant the 20,000 mini tubers at 55 cents a mini tuber. So that the seed grower in year one has to spend $60 an acre to $60 per hundredweight. $60 per hundredweight, that's per 100 pounds of seed. $60 per hundredweight to plant that acre with mini tubers. Then the next year, it now drops down to $20 per 100 pounds to plant the next generation. And you can see how the price is dropping. That's partly why potato growers multiply seed for so many generations, is because the commercial grower can't really afford to spend more than $15 per 100 pounds of seed, based on what they're going to get paid by the French fry producer or the chip producer. So that's the typical economics of seed. Here's what we project it will cost under this new system. So we eliminate the mini tubers from the operation. Now there's a greenhouse grower that produces the transplants. They get put in the ground, and the cost of the transplants, the equivalent cost of the transplants would be something like $20. I'm sorry, I'm misreading. I haven't looked at this slide in a while. The way this way, the number here is, this is the cost of the seed grown in field year one. So the field year one seed grown is worth $60 per hundredweight, versus now the embodied value is only $20 per hundredweight. Meaning that basically that seed grower of year one can sell their seed at much lower than someone who's still in the old system, right? The old system, they've already put into it $60 per hundredweight. They've got to sell it for at least that amount to make any profit. This grower, the one who adopts the new system, they've only sunk $20 per hundredweight into that seed. They could sell it for $30 and still, be equivalent to the profit of selling it for $70 per hundredweight under the old system. So as soon as we have something which is equivalent to our existing varieties, by the nature of the horticultural system, it's going to be a strong incentive for growers to adopt it, because they're going to be able to either match the price and have 3 times the profit, or they'll undercut the price and they'll take customers away from other competitors. That's what we envision as the strong driving force for that. And that's, again, if you have no genetic improvement at all, just matching whatever our current varieties can do, but converting them to a hybrid system. Well, we know that from a breeding perspective, the hybrid system can have many genetic improvements. We can do all the nice things that they can do with corn. We can do back crossing to introduce single resistances, which you can't do with potato right now. We expect to have a lot more value in the seed from a genetic perspective, which will then reduce the need for pesticides. Growers will be willing to pay more for their seed if they can cut down their pesticide costs. And you could potentially even reduce the number of generations required. That's a whole other aspect I didn't get into, but the question is, a commercial grower, what generation seed are they going to buy? Right now they buy generation 3 or 4. Initially they might be able to buy generation 2 or 3. Eventually we think they can buy generation 1 or 2. So you might even just have to have 1 year of seed production in Rhinelander, and you can take those small tubers and sell them directly to a commercial grower. Much more rapid time to getting new varieties to market. Instead of having to wait 5 years, right? When you say, oh, there's a new variety, why don't you go try it? Okay, 5 years later, I will have seed available. Now, maybe 2 years later, you'll have seed available. So we think it's going to stimulate drive a lot of change in the potato system. So that was a lot in a short period of time. Hopefully, I gave you some interesting things to think about, and be happy to take any questions. Thank you. Yeah.
So initially, my general question is, so some of these farmers can plant their own mini tubes or year after year after year? Is that and then sell them commercially?
The farmers that are in the certified seed program can replant their own seed if it's foundation class.
Okay.
If they only make certified class, they are not allowed to. They have to sell it to someone who's outside the foundation seed system.
Okay.
Yeah. And that's the main criterion is 0.5% of the critical virus that's called virus Y. If you're below that threshold, you can get foundation class to replant. If you're above that threshold, you are not allowed to because of the risk that it would then elevate levels in that protected area in Anago.
How far are you from having this commercially available?
The hybrid varieties, I would guess at least 10 years.
Another question on the big bins, and they got to be the right texture and all that kind of.
Mm-hmm.
How long can they be stored?
Yeah, well, I didn't call your attention to it, but this is you can see the months up there. So you harvest in October typically if it's a storage variety, late September, October in Wisconsin. So back to the Snowden variety that that was mentioned. Snowden came out in 1990. It was a breakthrough in terms of it allowed farmers to reliably store potatoes till March without, they could store them a little bit colder than they could before, and so they would keep well enough that they could fry them up in March. And then, and that was a big deal because the potato chip manufacturers, right, if you're running potatoes locally in Wisconsin and the potato chip plant needs to keep making potatoes, where are you going to get them from, right? You have to ship them, you have to ship raw tubers from maybe Texas or Florida. I mean, that's expensive freight to ship rail cars of tubers to a plant from Florida to Wisconsin to keep making potato chips locally. So there's a strong incentive to be able to store potatoes all the way until the next season, really. And the new variety, this is one of the breeding lines that was released that had a little bit better storage in terms of this, keeping that light color up until June, as you can see. And so we have varieties now that can store from October to even July. And August, you can start to get fresh crop harvested in Wisconsin if you plant early enough. So we almost have completely self-sufficient supply now of raw material for potato chips and French fries year-round in Wisconsin. That's one of the, there's a lot of talk about, well, what progress have potato breeders made in a century? There's data that shows that yield hasn't improved much in 50 years. The one trait you can definitely see improvement in is this trait because of the economic implications of it. We have definitely made progress for storability and this cold resistance to cold-induced sweetening in the last 50 years.
And that storage facility at Hancock was part of that research on the Hold'em for a whole year.
Yes, the advantage of that facility, you know, we store them there and in small crates. You can already assess this trait a little bit without having to have an 18-foot pile, but the bruising and the pressure, flattening as they call it, those are traits that are really hard to evaluate in any other system without access to tall commercial scale piles. So that's a real valuable facility for us.
And back in the old days, so a lot of seed corn working into it, moved to, and vegetable crops to Central Sands and rotating after potatoes. But there was a time 20, 30 years ago where the system was I'd call it self-cleaning. The potatoes couldn't be stored, so then the early potatoes coming out of Tennessee was the way to bridge that gap to keep them frying all year round. And it's really pretty nice. All of a sudden your competitions goes away. So if corn could just go away at the end of every year, we have a fresh crop every year, we wouldn't have to worry about that bin that's storing it for so long. So again, all these cycles kind of work in some combination. Question, for all of us, how did we get all of our Irish neighbors then?
The potato famine you're talking about?
Yeah.
Right, so that was lake blight, which was the disease that killed the Irish crop that year, and is still one of the most important diseases that we have. We still don't have genetic resistance to that in commercial potato. It's largely managed by fungicides. So it's still an important disease, but fortunately fungicides allow us to have reliable.
Yeah, it's a little hard to have organic potatoes, right?
There is some organic acreage, but yeah, it's hard to scale that up and managing, you know, copper can be used to some level, but there are downsides to copper. It's expensive, so yeah, it's not easy.
So I always got to weave in some political statement. So explain from the outside, if a fry made in the United States has 17 ingredients in that oil, and in some parts it's just salt and oil in a potato, what are all the other things that they put in the United States so they taste good? Because I think we're going to get a Kennedy who's going to take out a whole bunch of that stuff. What is all of that stuff? Anything from your viewpoint when they fry them with?
Well, I don't think not in the fryer per se, but I mean, there are. I mean, of course, there's seasoning, which is. But you're talking about. There are in potato chips.
Like in a McDonald's fry.
Yeah, McDonald's fries. They do play with some chemistry there. Making a traditional mac fry is a complicated. It's not just like you make strips of potato and you dump them in the fryer, right? They partially cook them. They partially cook them, then they're frozen, then they cook them a second time. This kind of parboiled, twice cooked creates that crispy exterior, which is it's originally a Belgian cooking technique. At least that's where I understand the word French fry comes from. When GIs came back from World War II, they were in French-speaking parts of Belgium and tasting something completely different than what they were used to in the United States. That's where the French fry expression came from. It's not from France, it's from Belgium. But they do sometimes use dextrose to try and change the color, because ironically they may have, they might want to add a little bit of sugar to actually add a little bit of color, because you get that darkening when you add.
So it isn't to make them sweet, it's to make them darker?
No, it's the color that they're primarily manipulating.
Oh, so. Silly me, I would have thought to make them sweet.
Yeah.
And then when Shamin and I visited, of course we went and buy a bunch of fryers, right? So that's got to be set that you're always testing them
right.
on the same fry.
At the Hancock station, we only do a very simple. This is a simple fry that is a strip that's just put in a fryer. You know, it kind of is really no more complicated than making a potato chip, which is good for looking at the color. The color you can assess, and you can see a little bit of the darkening here at the ends of the potato, because it accumulates sugar more at the stem attachment, so you get more darkening. It's called a sugar end in a French fry. Anyways, it's good for that. You cannot evaluate texture with that. You need this more complicated hard-boiled double fry type of operation to actually evaluate the texture. which we don't have a facility like that in Wisconsin. We have to partner with, the USDA has a facility like that in Minnesota. They do some for us, a very small number. And then actually the French fry companies themselves offer as a service. They collaborate, they help to organize a trial, a national trial, and any breeding program can put candidates in that trial. If they do well enough, they will run through their pilot plants a small number per year, and they are the ones who have the real culinary and sensory experts to give us that feedback about, does it get the nice crispy exterior, is it fluffy, et cetera, et cetera. So it's actually a very difficult culinary trait to
And then
breed
that
for.
becomes an approved list.
If it passes their characteristics, then McDonald's will then do their assessment, and they have their own experts. And eventually, if McDonald's says, yes, we allow this, when McDonald's says, we have now qualified a new variety to go into a Mac fry, that's considered the highest accomplishment for the French fry variety.
And if that happens for you enough times, then you're gonna retire early?
Well, yes, at least it will pay for my scuba trips as in retirement for sure, so, yeah. Good questions, thank you.
More questions? Very good,
All
thank you.
right.
And again, you can see at least the hand cutter, or Babcock facility, you can see it up the interstate, across the field. You'll see the storage shed there, and there's usually some nice flowers out by the road in the summer.
Yeah, they have a nice display garden there.
Right. Okay, well, thank you very much. And again, we help in doing some of the processing. Very good, thank you. Nice and convenient, we have all these kind of experts all here. There was an announcement by Shawn that if you wanted some
Purple.
Viking looking purple tomato seeds, they're available down the hall.
Mike Peters.
Right, Mike, yeah, so if anybody's into that, in other words, you Viking fans, right? A lot of Viking fans in here, right? Second, or another couple of ending points, we're considering a little bit of modifying this meeting time, at least a consideration. For instance, we'd like to have Dr. Tracy here, because he's very much part of our income and the fact that we collect royalties and some stuff for him. And that's always on top of, we think it's on top of these dates. So he's up at the Dells. He'd like to be speaking here. So we may do something there. And then I thought, since you're attending, any input on this particular day and this particular week, which was always Monday or Tuesday after Thanksgiving. Randy did bring up that occasionally it snows someplace between Kewanee and here in the winter as you go later.
Randy.
It's about Randy. We got him. It's going to be chairing every committee we got here, so we have to at least bring him up a little bit. Any other input? And it's just it's always been there, but we're just bringing it up because we want to get as much reaching out to the people, and Dr. Tracy is one. But he's always up. It's the vegetable conference at the Kalahari.
Yeah.
That's always the exact same time.
Yeah.
We think.
It is.
Yeah, and so sometimes those things rotate. I was president of Dane County Fair, and it was always on the third Thursday of July. Well, that date moved around based on when was the first Thursday. If it was on the 1st of the month, or it was on the 6th of the month. Now, we always play off of Thanksgiving, and I don't know how that one works, and heaven knows what determines when Easter is. Some ancient whatever of moonset. But anyway, and isn't, so we're just throwing that out there as a consideration. Other needed announcements, thoughts, ideas? Anything for Schminder? Did I forget everybody? We kind of announced everybody knows. And we are recording this. We're gonna have Mark figure out how we can make that available in some form that we can look at it. Good questions? If not, I thank you much.
Thank you. Thank you.